Tonight, we're about to embark on a journey that will change the way you perceive the universe. We're going to delve deep into the largest object ever discovered, an awe-inspiring cosmic structure that challenges everything we know about size, distance, and our place in the cosmos. By the end of this exploration, you'll look up at the night sky with a new understanding, realizing that the stars and galaxies we see are just a tiny fraction of what is really out there. If you enjoy these profound cosmic revelations, don't forget to subscribe or hit the like button. It helps us grow so we can continue these deep dives together. Let's begin with something more familiar, something that might feel small in comparison to what we are about to uncover. Imagine your house. The average house in America spans about 2,500 square feet. It's a space you could walk across in less than a minute, familiar and tangible. Your brain is wired to understand spaces like this. Areas you interact with daily, spaces you can see, touch, and walk through. This scale makes perfect sense to us because it aligns with our daily experiences. Now, let's step it up a notch. A football field, including the end zones, is 360 feet long. You could walk across it in about 2 minutes, or if you wanted, run across it in about 15 seconds. A mile is 5,280 feet, roughly equivalent to 17.5 football fields laid end to end. Most people can walk a mile in about 15 minutes, a distance that feels substantial but still very manageable. What if we zoom out even further? The distance from New York to Los Angeles is roughly 2,800 miles. That's a 5-hour flight or about 40 hours of continuous driving. It's a journey that feels large in scale, yet is nothing compared to what we'll encounter as we move out into the universe. And now, the truly mind-bending part. Earth's size. The circumference of Earth, measured at the equator, is around 24,901 miles. If you could drive around the planet without stopping and without slowing down, it would take you approximately 383 hours, or about 16 days of non-stop driving. But as vast as Earth's circumference might seem to us, it's only a speck in comparison to the vastness of the solar system. The Sun, which gives life to this little blue planet, is about 93 million miles away from Earth. If you could drive there at a constant highway speed of 65 miles per hour, it would take you about 163 years to reach it, passing the wheel from generation to generation. Light from the Sun, though, only takes about 8 minutes and 20 seconds to reach us. But as we move farther and farther out into the universe, we start to see just how small our home really is. A light year, astronomically speaking, is the distance that light travels in 1 year, and it's a unit designed to convey just how unfathomable distances are in space. Light travels at 186,282 miles per second. In 1 minute, that's nearly 11 million miles. And in 1 year, it's approximately 5.88 trillion miles. Now, let's put this in perspective. The nearest star to our solar system, other than the Sun, is Proxima Centauri, located about 4.24 light-years away. That's over 25 trillion miles. If you think about that in terms of time, it means that the light you're seeing tonight from Proxima Centauri left that star over 4 years ago. Every time we look at the stars, we're actually peering into the past. The further away a star is, the farther back in time we're looking. Our Sun resides in a galaxy we call the Milky Way. The Milky Way is about 100,000 light-years across. Now, let that number sink in. 100,000 light-years. If you were to travel from one edge of the galaxy to the other, it would take you, at the speed of light, 100,000 years. That's so far that the distance between stars in the Milky Way seems almost absurd to grasp. The light from stars you can see with your naked eye tonight, if you were able to catch it as it first left those stars, began its journey tens of thousands, or even hundreds of thousands of years ago. At this scale, Earth, and even our entire solar system, seems almost non-existent. But there's more. The Milky Way is part of a local group of galaxies that contains around 80 galaxies. But this is still just the tip of the iceberg. The Milky Way's size is puny in comparison to other larger structures in the universe. We're about to climb up the cosmic ladder and witness something that stretches beyond our wildest imaginations. The Virgo supercluster, for example, is an enormous collection of galaxies, measuring a staggering 110 million light-years across. Within this vast supercluster, the Milky Way is just a small dot, but the Virgo supercluster isn't even the largest known structure in the universe. Here's where things take a fascinating turn. In 2014, astronomers discovered a structure called Lania, which is even bigger. This structure spans an immense 520 million light-years, encompassing 100,000 galaxies. If the Milky Way were the size of a quarter, Lania would be the size of the entire United States. But Lania, massive as it is still not the largest known structure in the universe. As you might have guessed, we are heading toward an even more profound discovery. Are you ready? At the outermost edges of our cosmic understanding lies a discovery so staggering that it challenges everything we thought we knew about the size and structure of the universe. This discovery, named Quipu, has been identified as the largest coherent structure ever observed, spanning an almost incomprehensible 1.4 billion light-years. And it's not just big. Its mass is estimated to be 200 quadrillion times that of our Sun. That's 200 quadrillion solar masses, a number so vast it defies meaningful comprehension. What's even more astonishing about Quipu is that it's not just a random scattering of galaxies. Instead, the galaxies are intricately connected, forming a massive web-like structure. It's as if we've stumbled upon the backbone of the universe itself. In the next section, we'll break down the discovery of Quipu, how it was detected, and what it means for our understanding of the cosmos. Now that we've encountered the astonishing scale of Quipu, a structure spanning 1.4 billion light-years, let's dive deeper into the details of this cosmic discovery. As we unravel the mysteries of Quipu, we not only stretch our understanding of the universe, but we also face a deeper realization about the limits of our knowledge. What makes Quipu so unique isn't just its massive size, it's the way it was detected. This behemoth was found not by traditional optical telescopes, but by the cutting-edge X-ray emissions from the hot gas surrounding galaxy clusters. Quipu, like a spider's web, is a network of galaxy clusters that stretch across an unimaginable distance, forming the largest known coherent structure in the observable universe. To understand why this is so remarkable, let's step back and look at the cosmic web, the overarching structure that shapes the universe. Imagine a vast three-dimensional spider web, where the strands are made of galaxies. The nodes where these filaments intersect are massive galaxy clusters, and in between these strands are immense voids, regions where almost nothing exists. Over the past few decades, scientists have mapped parts of this cosmic web, revealing a universe that isn't scattered randomly, but is organized into filaments, clusters, and voids. However, Quipu represents a stunning exception. Astronomers who discovered Quipu, using data from the Rosat satellite, along with other surveys, identified an incredibly dense concentration of galaxy clusters all aligned across vast stretches of space. Unlike earlier massive structures, which were found in different parts of the universe and often questioned for their true coherence, Quipu stands apart as a confirmed, connected structure. The X-ray emissions from the gas between these galaxy clusters form a network that shows undeniable connections between them, stretching across an area of space so vast that it boggles the imagination. In total, 68 galaxy clusters make up Quipu, and it's not just their proximity that's fascinating. These clusters are gravitationally bound to each other, drawn together by the invisible threads of dark matter. But Quipu isn't just about the galaxies themselves. The real magic lies in how these clusters are interconnected by vast filaments of dark matter and hot gas. The universe isn't just full of galaxies and stars, it's threaded with invisible structures, the scaffolding that holds the visible universe together. Each of these 68 galaxy clusters within Quipu is already a massive structure in its own right. Some contain thousands of galaxies. These galaxies are themselves packed with hundreds of billions of stars, and within those stars are untold numbers of planets, some of which might harbor life. It is a living, breathing structure, constantly evolving as gravitational forces continue to shape and refine it. The discovery of Quipu isn't merely an intellectual victory for astronomers. It forces us to confront an essential question. How did such a massive structure form, And what does this tell us about the history of the universe itself? The key to answering this lies in understanding the role of dark matter. When we examine Quipu, we see that each of its 68 galaxy clusters is embedded in a dense halo of dark matter. These halos are the unseen frameworks that provide the gravitational pull needed to keep the galaxies and the gas within the cluster intact. Unlike ordinary matter, dark matter doesn't emit or interact with light in any measurable way, which is why we call it dark. Instead, dark matter reveals itself only through its gravitational effects, bending the paths of light from distant galaxies, or influencing the movement of galaxies themselves. The discovery of Quipu underscores the central role of dark matter in the formation of the largest structures in the cosmos. Without dark matter, galaxy clusters like those in Quipu would not be able to hold together, and the formation of such a vast, interconnected network would be impossible. But Quipu isn't just about dark matter. The hot gas that fills these clusters plays a critical role in understanding the structure's evolution. This gas is heated to millions of degrees by the gravitational collapse that formed the galaxy clusters, glowing brightly in X-rays that we can detect from Earth. In many ways, this hot gas is the glue that binds the visible structure of Quipu together, serving as both a tracer for the invisible dark matter and a dynamic force in its own right. This gas doesn't just sit there, it moves, flows, and interacts with other clusters in complex and fascinating ways. Understanding the behavior of this gas and its relationship with both the dark matter and the galaxies themselves will be essential for understanding the true nature of Quipu. One of the most challenging aspects of Quipu's discovery is the sheer complexity of its formation. The X-ray emissions that allowed astronomers to detect it are not just a byproduct of the structure's existence, they are a map of Quipu's evolution. The connections between the galaxy clusters, visible as faint X-ray bridges between them, reveal that Quipu is not just a random arrangement of galaxies, it is a coherent, connected system formed over billions of years of cosmic evolution. But how did these galaxy clusters come together in such a precise way, and why are they connected along such a vast network? Astronomers have several ideas. One possibility is that Quipu formed through a process of gravitational collapse, where vast amounts of matter, drawn together by the force of gravity, began to merge over billions of years. But this process would have required an incredibly delicate balance. For the clusters to form in such a precise network, the early conditions in the universe, shortly after the Big Bang, had to have been just right. Perhaps there were slight variations in the density of matter that gave rise to the formation of such a colossal structure. Or perhaps there's something about the early universe, the tiny density fluctuations that seeded all the matter we observe today, that we don't fully understand. What is clear is that Quipu represents a profound challenge to our models of structure formation in the universe. According to standard cosmological models, structures this large shouldn't form so quickly, certainly not within the 13.8 billion years of the universe's history. The existence of Quipu forces cosmologists to rethink their assumptions about how structures like this come into being, and it pushes the boundaries of what we know about the evolution of the cosmos. This discovery also underscores an even greater mystery: what lies beyond Quipu? If such an enormous structure exists within our observable universe, what else might be out there, beyond the reaches of our telescopes? And could there be even larger structures beyond our cosmic horizon waiting to be discovered? These questions lie at the very edge of human knowledge. The discovery of Quipu is both a triumph and a mystery, a reminder that the universe is far more complex and vast than we ever imagined. As we continue to probe the depths of space, we will surely uncover more structures like it, each one challenging our understanding of the cosmos, expanding the limits of what we thought was possible, and revealing the deepest secrets of the universe. What we can say for certain is this: Quipu is not an anomaly. It is the largest known coherent structure, but it may be just one of many such structures scattered across the universe. And as our telescopes grow more powerful, we may yet find others that stretch the boundaries of our imagination even further. What happens next? As we look toward the future of astronomical research, the discovery of Quipu will shape the way we understand cosmic structure. New telescopes, new surveys, and cutting-edge technology will allow us to delve deeper into the cosmic web, studying galaxy clusters filaments, and voids with unprecedented detail. The next steps are not just about discovering more, but about understanding these structures, why they exist, how they form, and what they tell us about the evolution of the universe. The universe is vast, full of mysteries and wonders that defy comprehension. But as we continue our journey of discovery, we grow ever closer to understanding our place in this grand interconnected web of existence. And perhaps in that understanding, we will unlock the secrets of the cosmos itself. As we dive even deeper into the nature of Quipu, we are forced to confront a question that lies at the heart of modern cosmology. What is the fundamental architecture of the universe? To grasp the significance of Quipu, we must not only appreciate its size and mass, but also explore the invisible forces at play, shaping everything we see and cannot see. Dark matter and dark energy, the mysterious components that make up most of the universe's content, have a crucial role in the formation of structures like Quipu. The role of dark matter in Quipu: we've already encountered the concept of dark matter, but understanding its role in the formation of structures like Quipu requires further exploration. In fact, dark matter makes up about 85% of the mass in the universe. It doesn't emit, absorb, or reflect light, which is why it's so hard to detect. Despite its invisibility, we know it exists because of its gravitational effects on visible matter, light, and the structure of the universe itself. It's the gravitational glue that holds galaxies, clusters of galaxies, and even the large-scale cosmic structures like Quipu together. If dark matter didn't exist, structures like Quipu would not be stable. Without it, galaxy clusters would disperse, and the filaments connecting them would unravel. What's fascinating is that Quipu is an intricate tapestry of galaxy clusters, connected by filaments of dark matter and hot gas. These clusters aren't randomly scattered, they are organized by the unseen hand of dark matter, woven together into a coherent and stable structure. But dark matter is not just a passive observer in the formation of Quipu, it actively shapes the structure of the cosmic web. The formation of galaxy clusters, like those within Quipu, is driven by the clumping of dark matter. In the early universe, slight variations in the density of dark matter served as gravitational seeds. As these fluctuations grew over billions of years, they pulled in gas, stars, and galaxies, creating the massive clusters we observe today. Without dark matter's influence, these galaxy clusters would never have come together. However, what makes Quipu so mind-boggling is that the dark matter halos surrounding these galaxy clusters are not uniform. Some clusters are larger and denser, while others are more sparsely connected by longer filaments. This creates a dynamic structure, a living cosmic organism, constantly changing and evolving as it reacts to the forces around it. Yet even dark matter, with all its gravitational power, isn't the only force at play. The hot gas between these galaxy clusters is another critical component of Quipu, revealing a different layer of the structure's nature. This gas, heated to millions of degrees by the formation and merging of clusters, glows in X-rays, allowing astronomers to trace its presence. This is the glue that binds the galaxy clusters together, filling the vast space between them, connecting them in a way that is only visible through these X-ray emissions. The gas in galaxy clusters isn't just there for show, it is also responsible for some of the most energetic processes in the universe. When galaxy clusters collide, which happens frequently in cosmic time, the gas between them interacts violently. Shocks are created as the clusters pass through each other, heating the gas to even higher temperatures and triggering star formation in the process. These collisions are not just cosmic events, they are cataclysmic, shaping the evolution of the entire cluster. And yet, even as these events unfold, we must return to the core mystery. How does Quipu fit into the grand narrative of the universe? The enigma of Quipu's formation. Quipu is a cosmic anomaly, not because it shouldn't exist, but because it defies the timeline we expect for structures this size. According to current cosmological models, it should have taken longer for such an immense structure to form. After all, the universe is only about 13.8 billion years old, and Quipu spans an almost unimaginable distance of 1.4 billion light-years. If we follow the timeline of the universe's evolution, it's unclear how such an enormous network could have come into existence so quickly. This paradox forces us to reconsider how large-scale structures like Quipu emerge. One possibility is that the early universe had conditions that allowed these structures to form faster than we initially thought. The fluctuations in the early universe that led to dark matter clumping together might have been larger and more pronounced than current models predict. If the density variations were stronger, it could explain why structures like Quipu formed more rapidly. Alternatively, there could be unaccounted for factors, perhaps related to the behavior of dark matter or even dark energy, that we have yet to fully understand. The influence of dark energy, the force accelerating the universe's expansion, could have played a role in slowing down the growth of structure. But we've only just begun to understand how dark energy works on cosmic scales. If we want to grasp the significance of Quipu, we have to consider its formation as a product of both the known physics and the unknown forces at play in the universe. These structures don't simply form in isolation. They emerge from the intricate hidden interactions between visible matter, and dark energy. We are in the process of rewriting the textbooks on how cosmic structures evolve, a window into the past. Quipu's cosmic history, one of the most remarkable aspects of Quipu, is that it provides a window into the past, not just of our universe, but of the cosmic web itself. The distance to Quipu means that the light we see from its galaxy clusters has been traveling toward us for millions of years. The closest clusters in Quipu are about 425 million light-years away, while the farthest are over 800 million light-years distance. This means we're not seeing Quipu as it is today. We're seeing it as it was hundreds of millions of years ago. In effect, we are looking back in time. This is not just a cosmic curiosity, it's an incredibly powerful tool for astronomers. By studying different distances within the structure, we can learn how the universe has evolved. The closer galaxy clusters show us the universe as it was when it was only about 425 million years old. The farthest clusters reveal a much older cosmic past, showing us how the universe looked nearly 800 million years ago. This gives astronomers a rare opportunity to see how structures grow over time. What this time-shifting perspective reveals is that the universe is not static. It is a dynamic, evolving system. Over the course of hundreds of millions of years, the galaxy clusters in Quipu have merged with others, and some are still in the process of merging today. The filaments that connect these clusters are stretching and evolving. Matter is flowing into them. Galaxies are colliding, and the dark matter and gas between them are adjusting to the new structure. Dark matter's hidden role in cosmic evolution. The hidden scaffolding that holds Quipu together is the dark matter connecting the galaxy clusters. As the structure grows, the gravitational pull from the dark matter filaments continues to attract galaxies, forming an even tighter bond. Dark matter doesn't just create clusters. It shapes the paths of galaxies, guiding them into place, ensuring they are connected across massive distances. Without dark matter, there would be no Quipu. There would be no cosmic web, no large-scale structure to connect the galaxies. But what does this mean for our understanding of dark matter itself? The fact that Quipu exists tells us that dark matter behaves differently on cosmic scales than we might have expected. It's one thing to observe dark matter in the gravitational effects it has on galaxies, but to see it actively shaping the largest structures in the universe forces us to ask deeper questions about how dark matter operates over time and space. The discovery of Quipu pushes the boundaries of what we know about the universe's structure and the forces that govern it. What's even more fascinating is that as Quipu continues to evolve, it will continue to tell us new stories about the formation of the universe. By examining the gravitational effects of dark matter within Quipu, we are piecing together a narrative that spans billions of years, a tale of cosmic evolution written across the vast expanse of space. As we continue to explore the mysteries of Quipu, we find ourselves standing on the precipice of discovery, peering into the cosmic web that stretches across the observable universe. The sheer magnitude of this structure, its interconnected galaxy clusters, and the role of dark matter and hot gas in shaping the cosmic landscape make Quipu an extraordinary enigma. But beyond the immediate fascination with Quipu itself, the discovery invites us to confront profound questions about the nature of the universe, time, and the forces that govern everything. The intricacies of cosmic evolution, one of the most compelling aspects of Quipu, is that it offers us a glimpse into the evolution of the universe on a scale that has never been possible before. While the discovery of Quipu is groundbreaking, it is also a testament to the long journey of cosmic evolution, a journey that spans billions of years and has shaped the universe into what we see today. The universe, as we know it, began with the Big Bang roughly 13.8 billion years ago. In the aftermath of this explosion, the universe was a hot, dense place. There was no structure, just an expanding sea of particles. But over time, this seemingly uniform expansion began to show slight density fluctuations, which would serve as the seeds for all the structure we see today: stars, galaxies, clusters, and superclusters. These initial density variations were tiny, mere ripples in the fabric of space and time, but they grew larger under the influence of gravity. Dark matter, with its mysterious properties, played a crucial role in this process by pulling matter together and helping to form the very structures we observe today, including Quipu. The question we must now ask is, how did Quipu come to be? What role did the early universe play in shaping this colossal network of galaxy clusters, and how did these clusters interact with each other across vast stretches of space? Understanding the formation of structures like Quipu, the formation of a structure like Quipu is not instantaneous. It requires billions of years of gravitational interaction, mergers, and accumulation of matter. The evolution of a galaxy cluster, like the ones in Quipu, starts long before the galaxies themselves take shape. In the early universe, dark matter halos formed first, gathering matter through gravity and accretion. These halos provided the foundation for galaxy formation, acting as the invisible scaffolding that shaped the distribution of galaxies. As the universe continued to evolve, these dark matter halos began to grow in size, merging with other halos and eventually forming galaxy clusters. But the growth didn't stop there. Over time, galaxy clusters merged, pulling in surrounding galaxies and gas, building up mass and forming dense centers that would eventually become the heart of a galactic supercluster, like Quipu. The hot gas that fills the spaces between galaxies in clusters plays a significant role in this process. This gas, heated to millions of degrees by gravitational compression, forms a critical link between the galaxies. It fills the empty space between them, binding them together, and is responsible for emitting X-rays, allowing us to detect the presence of these clusters from light years away. As clusters collide and merge, the gas within them heats up, and the galaxies themselves undergo dynamic changes. They might be stripped of gas, distorted, or even ejected from the cluster entirely. These cosmic collisions can take billions of years, creating new galaxies and triggering waves of star formation. The dynamics of these mergers, along with the impact of dark matter, are what make Quipu such a dynamic and living structure. But Quipu's growth doesn't just stem from gravity and gas. The role of dark energy, the mysterious force accelerating the expansion of the universe, also plays a significant part in its formation. Dark energy acts against gravity, pushing galaxies and clusters apart. As the universe expands, it challenges the growth of structures like Quipu, slowing down the merging of clusters and stretching the filaments that connect them. Dark matter, the invisible force behind Quipu. The force that holds Quipu together is dark matter, an unseen, enigmatic substance that makes up 85% of the universe's mass. While dark matter cannot be directly detected because it doesn't interact with light, it exerts a profound gravitational pull on visible matter. This gravitational influence is what allowed structures like Quipu to form in the first place. The galaxy clusters in Quipu are gravitationally bound by dark matter. Without it, these clusters would never have come together to form a coherent structure. Dark matter doesn't just hold the galaxy clusters in place, it also shapes the paths that the galaxies follow. The filaments of dark matter serve as highways, guiding galaxies toward the clusters, feeding them with more material, and ultimately contributing to the growth of structures like Quipu. The X-ray emissions that allowed astronomers to detect Quipu are another clue about dark matter's role. As the gas in galaxy clusters heats up and forms hot plasma, it glows in X-rays, revealing the intricate structure of the clusters. But this glow is not just a byproduct of the gas, it's also shaped by dark matter, which serves as the invisible backbone of the cosmic web. By mapping these X-ray emissions, astronomers can observe the distribution of dark matter, helping us understand how it connects and shapes the galaxies. However, dark matter is not just a passive observer in this process. The gravitational pull of dark matter helps accelerate the mergers between galaxy clusters. These mergers, which take billions of years, are a cosmic dance driven by gravity and dark matter. But despite the dramatic energy involved in these collisions, the galaxies themselves don't collide directly. The vast distances between stars ensure that they pass by each other largely unscathed. Instead, the gas between them interacts, creating shockwaves and triggering new bursts of star formation. Cosmic time and Quipu's evolution. The cosmic history of Quipu unfolds over an immense timescale stretching back billions of years. If we could somehow witness the formation of Quipu in real time, we would see clusters of galaxies slowly coalescing, merging and growing over eons. The distance between each cluster is so vast that their interactions unfold on timescales far beyond human comprehension. For comparison, the light that reaches us from Quipu's most distant clusters left those galaxies 800 million years ago. In that time, the universe has undergone dramatic changes. Stars have been born, galaxies have formed, and some stars have already died, their remnants enriching the interstellar medium with heavy elements. In a sense, by studying Quipu, we are observing a cosmic historical record, a snapshot of the universe at a particular stage of its evolution. We're seeing the clusters as they were 800 million years ago, and in that time their structures have changed significantly. Some clusters have merged, while others remain on the brink of collision. Some are feeding on new gas, while others are slowly losing their material to neighboring clusters. But the story doesn't end here. As the universe continues to expand and dark energy exerts more influence, the growth of structures like Quipu will slow down. The universe's expansion will continue to push galaxies apart, and the intricate filaments that connect the clusters will thin out. The cosmic web, once a vibrant, growing structure, will eventually freeze in place, locked in its final configuration. This is the far future of Quipu, a structure that, while magnificent in its current form, will one day be part of a vastly different universe. The future of Quipu and the expanding universe. As we peer into the distant future of Quipu and the universe as a whole, we must consider the impact of dark energy on its evolution. Over the next few billion years, the influence of dark energy will dominate. This will cause the expansion of space to accelerate, and the merger of galaxy clusters will slow to a halt. The filaments that once connected galaxies will become less dense, and the clusters within Quipu will eventually become isolated. The structure will still persist, but it will be surrounded by an ever-expanding void as the rest of the universe recedes beyond our ability to observe. In the far future, Quipu will be an isolated relic, a vast network of galaxies and clusters suspended in an ever-expanding universe. Its connections to other cosmic structures will slowly fade, and the once thriving cosmic web will become a fossil, preserved only in the distant memory of the universe. As the universe continues to expand, Quipu will persist, but its role in the cosmic story will shift. No longer a growing dynamic structure, it will become a frozen monument to the complex and awe-inspiring processes that shaped it. Yet even as the universe becomes more isolated, we will continue to study structures like Quipu, learning from them and gaining new insights into the workings of the cosmos. The eternal dance of gravity and dark matter. As we continue to study the largest structures in the universe, such as Quipu, we come face to face with the forces that govern the cosmos. Gravity and dark matter are the two main players in shaping the universe's structure, and together they create a dynamic cosmic environment that is always in motion. These forces are responsible for the formation of stars, galaxies, and clusters, as well as the vast filaments that make up the cosmic web. When we think about gravity, it's easy to imagine it simply as the force that keeps us anchored to the Earth. But in the grander context of the universe, gravity is the architect of cosmic structure. It's the reason galaxies form, why they collide, and why they eventually merge into massive galaxy clusters. The pull of gravity causes matter to collapse in on itself, creating dense regions of stars, gas, and dark matter. Over time, these regions evolve into the superclusters and galaxy clusters that form the backbone of the cosmic web. But gravity alone cannot explain the full picture. Dark matter, the invisible substance that makes up about 85% of the universe's mass, is just as essential in shaping the cosmos. It doesn't interact with light or ordinary matter in any detectable way, but its gravitational pull is profound. Dark matter does not shine or emit any radiation, yet it exerts such a powerful influence that it can bend light and shape the motion of galaxies. It is the unseen scaffolding upon which the entire structure of the universe rests. In Quipu, dark matter's influence is felt most strongly. Each of the 68 galaxy clusters that make up this immense structure is embedded in a halo of dark matter. These dark matter halos serve as the gravitational glue, keeping the galaxy clusters bound together across billions of light years. The filaments of dark matter that connect these clusters form the pathways through which matter flows, pulling galaxies into the larger cosmic structure over vast periods of time. What makes dark matter so mysterious is that we can't directly observe it. We don't know what it's made of, only that it has mass and gravitational influence. Yet its presence is felt everywhere. Without dark matter, Quipu would never have formed in the first place. The galaxies and clusters would have dispersed into space, unable to stay bound by gravity alone. This revelation challenges our understanding of what the universe is made of and how it works. The role of hot gas in the cosmic web. As we observe Quipu, we begin to notice the hot gas that permeates the space between galaxy clusters. This gas, known as the intracluster medium, is heated to millions of degrees as it is pulled into the gravitational wells of the galaxy clusters. It doesn't just serve as a passive bystander. The hot gas plays an active role in shaping the evolution of galaxy clusters. This gas is the energy source that allows galaxies to form, grow, and interact. When galaxy clusters merge, they bring their gas with them. The collision of these vast clusters creates shock waves that further heat the gas, triggering new star formation. The process is violent, yet essential for the growth and evolution of galaxies within the clusters. This star formation occurs when gas cools and condenses under the influence of gravity, forming new stars. However, the gas in the center of the cluster is not always allowed to cool. Active galactic nuclei, AGN, powered by supermassive black holes at the center of galaxies, release enormous amounts of energy in the form of jets and radiation, preventing the gas from cooling too quickly. The X-ray emissions from this gas are what allow us to study galaxy clusters and structures like Quipu. These emissions are a direct indicator of the presence and dynamics of the gas. By studying the X-rays emitted by the gas, astronomers can map the distribution of gas in the cluster, as well as measure its temperature and density. This gives us valuable insights into the structure and evolution of galaxy clusters. Moreover, the gas in these clusters isn't uniform. It flows and interacts in complex ways, influenced by the gravitational forces of dark matter and the galaxies themselves. As clusters grow and merge, the gas between them forms intricate bridges and filaments, creating a web-like structure that connects the galaxies. These gas filaments are the structural connectors of the cosmic web, allowing matter to flow from one cluster to another, feeding the growth of new galaxies along the way. The cosmic web and the evolution of structures. The cosmic web is a three-dimensional structure that connects galaxies, clusters, and superclusters across vast distances. It is not a random scattering of galaxies, but an organized network of matter, shaped by gravity and dark matter. As we look at Quipu, we see that it is just one part of this vast web, a network of clusters connected by filaments of dark matter and gas. What's fascinating about the cosmic web is how it has evolved over time. The early universe was nearly uniform, with only tiny fluctuations in density. However, as gravity acted on these fluctuations, matter began to clump together. Dark matter halos formed first, attracting gas and eventually galaxies. Over billions of years, these galaxy clusters and filaments grew, merging into larger structures like Quipu. The evolution of the cosmic web is still ongoing. As dark energy accelerates the expansion of the universe, the growth of structures like Quipu will slow. The filaments that connect galaxy clusters will become longer and thinner, eventually becoming isolated. The universe is slowly being stretched apart, and the once connected cosmic structures will become increasingly distant from one another. However, this process of isolation is not an immediate event. it will take billions of years for the cosmic web to stretch to the point where the connections between clusters and superclusters are severed. During this time, the structure of the universe will continue to evolve, with galaxy clusters merging and growing, and new filaments and voids forming. The inevitable fate of the universe. As we look to the far future of Quipu and the larger cosmic web, it's impossible to ignore the inevitable fate of the universe itself. The universe is expanding, and as it does, the distance between structures like Quipu will continue to grow. This expansion is driven by dark energy, a mysterious force that has accelerated the expansion of the universe since the Big Bang. The growing influence of dark energy will eventually overpower the gravitational forces that hold galaxy clusters together. As a result, structures like Quipu will be torn apart, and the galaxies within it will become isolated from one another. Over billions of years, the cosmic web will lose its interconnectedness, and the universe will become increasingly empty. The far future of Quipu is a stark contrast to its current state. Today, it is a dynamic and evolving structure, constantly interacting with the forces of gravity and dark matter. But in the future, it will become an isolated remnant of the cosmic web, a silent monument to the forces that once held it together. As the universe continues to expand, it will eventually reach a point where all galaxies are too far apart to interact. The cosmic voids will grow larger, and the stars within the galaxies will burn out, leaving behind only remnants of their former selves. The supermassive black holes at the centers of galaxies will continue to exist for billions of years, slowly evaporating through Hawking radiation. The end of cosmic evolution? In the distant future, the universe will become a dark, cold, and empty place. The cosmic web will have disintegrated, and the only remaining traces of the once thriving structure will be the remnants of dark matter and black holes. The last stars will have burned out, and the galaxies will be scattered across an increasingly empty universe. For us, here in the present, this distant future seems unimaginable. It's difficult to grasp that the universe we see today will one day be gone. But that's the nature of the universe. It is constantly evolving, constantly changing. What we see now is just one moment in its long, unfolding history. The expansion of the universe is a never-ending process, and with each passing moment, the universe inches closer to its ultimate fate. Yet, even as the universe fades into darkness, Quipu will remain as a relic, a reminder of the incredible forces that shaped it. The story of Quipu and the cosmic web is not just a story of galaxies and clusters, it's the story of the universe itself, evolving over vast timescales and forces we can barely comprehend. The cosmic web, a fragile balance between chaos and order. When we look at Quipu and other cosmic structures, we are witnessing something that in its very essence is a fragile balance between order and chaos. The cosmic web that connects galaxy clusters and superclusters across vast distances is a delicate network formed over billions of years by forces that we still only partially understand. These cosmic filaments and voids, filled with dark matter and gas, appear as though they were designed by some hidden hand, but in reality, they are the product of gravity, dark matter, and the expansion of space itself. At its core, the cosmic web is driven by the gravitational pull of dark matter. This unseen, mysterious substance makes up the majority of the mass in the universe, and its role in shaping the large-scale structure of the cosmos cannot be overstated. As dark matter collects and forms halos around galaxies, it guides the flow of matter, pulling galaxies together to form clusters and superclusters. These clusters, in turn, grow larger over time, connected by filaments of dark matter and gas. But while gravity and dark matter are the architects of the cosmic web, dark energy plays a crucial role in its future. As we've seen, dark energy is responsible for the accelerating expansion of the universe. While this force has stretched the universe over billions of years, it also means that the cosmic web is ultimately doomed to stretch too far, too fast. The expansion of the universe is pulling galaxies apart, and as this acceleration continues, the connections between the galaxy clusters in Quipu will weaken and eventually vanish. However, the cosmic web isn't just a static structure, it's a dynamic process that evolves over time. The formation and merging of galaxies and clusters is ongoing, and we can observe this process even today. But this expansion and merging are happening more slowly now, as the force of dark energy continues to battle against the gravitational pull of matter. The result is a complex, interconnected web that grows, changes, and eventually slows down as the universe drifts towards isolation. This transition, from a dynamic, growing cosmic web to an isolated and fragmented state, is a reminder of the ephemeral nature of cosmic structures. The universe, once a dense and chaotic mix of matter and energy, is now in a state of expansion, with the forces that once held it together gradually losing their grip. Dark energy's impact on the cosmic web. Dark energy is the force responsible for the accelerating expansion of the universe. It acts counter to gravity, causing galaxies and clusters to drift farther apart. When the universe was young, gravity dominated, causing matter to collapse and form structures like galaxies. But as the universe expanded, dark energy began to exert more influence. This force pushed matter apart, working against gravity's attempt to pull it together. At first, dark energy's effect was minimal, but over time it became stronger. About 5 billion years ago, dark energy began to dominate, accelerating the expansion of the universe. This acceleration has profound implications for the future of the cosmic web. As the universe continues to expand at an increasing rate, the connections between galaxy clusters will weaken. The filaments of dark matter that once bound galaxies together will stretch and become more tenuous. Eventually, Quipu, along with other large-scale structures, will experience isolation. The once vibrant, interconnected cosmic web will become a relic, a series of lonely, disconnected galaxy clusters scattered across an ever-expanding void. Dark energy's influence will cause the cosmic web to unravel over time. Quipu, currently a massive structure spanning over 1.4 billion light-years, will become an isolated collection of galaxy clusters, drifting farther apart as space expands. The universe's large-scale structures will gradually dissipate, leaving behind a cold, dark, and largely empty cosmos. This inevitable isolation is the future of the cosmic web, and it's a fate that will eventually befall all structures within the observable universe. While the expansion of the universe isn't happening instantaneously, the accelerated rate at which galaxies are moving away from each other means that the process is happening at an ever-increasing pace. The universe is not just expanding, it's stretching, and stretching faster and faster with each passing moment. The fading of galaxy clusters and the final days of the cosmic web. In the distant future, as Quipu and other large-scale structures drift apart, the galaxy clusters within them will begin to lose their defining characteristics. As dark energy continues to dominate, the gravitational pull that once held the clusters together will weaken. This means that the galaxies within these clusters will begin to drift apart, eventually becoming isolated in the vast voids between clusters. As galaxy clusters merge, new structures are born and the growth of the cosmic web continues. However, this process will slow over time. With the universe expanding at an increasing rate, new mergers will become less frequent. The final mergers will be rare and will take place over timescales so long that they will likely be unnoticeable to any observers. Eventually, the galaxies within these clusters will become the last survivors of an otherwise empty universe. Their stars will continue to burn for billions of years, but eventually, even they will burn out. The last stars in the universe will be small, dim, and eventually fade away, leaving behind a cold and dark cosmos. The final days of the universe will be marked by the death of the stars and the isolation of galaxy clusters. In these last moments, only the supermassive black holes at the centers of galaxies will remain. These black holes, which are the densest and most gravitationally intense objects in the universe, will continue to exist for trillions of years before eventually evaporating through Hawking radiation. Over time, the cosmic web will break apart completely, leaving behind a few scattered remnants of a once thriving network of galaxies. Understanding the vastness of Quipu and its role in the universe, as we reflect on the sheer size and scale of Quipu, it's essential to recognize its place in the larger cosmic story. Quipu is not just the largest known coherent structure in the observable universe, it's a cosmic marker that allows us to understand the very nature of the universe itself. It's a structure born from the gravitational forces that shape the cosmic web, and it's a reminder of the immense power of dark matter, gravity, and cosmic evolution. But Quipu also tells us something deeper about the universe's finite nature. Its isolation in the future serves as a symbol of cosmic change. Time is the great architect of the universe's fate. Over the course of billions of years, we have witnessed the birth of galaxies, the formation of superclusters, and the gradual evolution of cosmic structures. But we are also witnessing the slow death of these structures as dark energy accelerates the universe's
One was observed on
expansion.
an exoplanet.
In a way,
This
Quipu
finding
is a
could
cosmic
revolutionize
artifact,
our
a
understanding of
relic of a
planetary
time when the
atmospheres and
universe was more
atmospheric
connected,
phenomena.
more compact,
The glory on
and more
WASP,
vibrant. It represents a
76b,
phase in the
would
life
be
of the
visible
cosmos
in a
that
narrow
is now
band
slowly
between the planet's
fading
day
away,
and night
but its
sides.
existence
And if
also reminds
confirmed,
us of the
this would be
immense
the first
complexity
time such an
and
event
beauty
was
of the
witnessed
universe's design.
outside our solar
Quipu,
system.
a monument to the universe's
76
evolution in
B
the
is a
grand
prime
scope of the
example of the
universe's
kinds of planets
timeline.
that continue to
Quipu will
surprise
eventually
and
be
intrigue
remembered as one of the
astronomers,
most
but it's
impressive
far
and
from the only
short-lived
one.
structures in
As
the
we
cosmic
explore
web.
further,
Its
we will
enormous
encounter
scale
even
and intricate
stranger
formations
worlds,
make it a
some of which
testament
seem
to
to
the
fall
forces
straight
and
out
laws
of
of
science
physics that
fiction
govern the
novel,
universe,
and others that
It is
challenge
both
our
the symbol of the
understanding of how
universe's
planets
birth
can
and death,
form and exist
a
in the
monument to
first place.
cosmic evolution,
One such
and the
world is
relentless
55
march of time.
Cancri,
But just
a
as
planet
stars are
located
born,
40
burn
light-years
brightly,
from Earth
and
in
die,
the Cancer
so
constellation,
too do the structures they
At
form.
first glance,
Quipu
55
will eventually
Cancri
fade,
might
just
appear
as
to be a
everything in the
relatively
universe
ordinary
eventually
super
fades.
Earth.
A
The
rocky
ultimate
planet
fate
that
of
is more
Quipu
massive than
is
Earth.
tied to the fate
However,
of the
it has
universe
a
itself.
remarkable secret:
Isolation,
This planet is essentially
emptiness,
made of
and
diamond.
the slow death of the
55
stars.
Cancri is
Yet
composed
even in its
mainly of
eventual
carbon,
decay,
and the
Quipu
extreme
will leave
pressure
a
and
lasting
heat it
legacy.
experiences from
It will
its
continue
close
to be a
orbit around
monument
its
to the
star
forces of gravity
that turned
and
that
dark
carbon
matter
into
that
diamond.
gave it life.
The planet's surface
And for us,
is likely
as observers
covered
of
in
the
vast
cosmos,
oceans
its
of molten
discovery
rock.
represents a
And while
major
the idea
milestone
of a
in our
diamond planet
understanding of
sounds
the
like
universe.
something out of
It
a
reminds us
fantasy,
that even in the
it's a
face
very
of
real
cosmic isolation,
possibility. There is
supported
still
by
beauty,
astronomical
order,
observations,
and meaning to be
but
found
55
in the vast,
Cancri is
mysterious
not just
expanse
remarkable
of the
for its
universe.
composition.
The final days
It's
of
also
cosmic
an
evolution,
incredibly hostile
from
world.
isolation to silence.
The planet
as the
orbits its
universe
star
expands
in just
and
18
ages,
hours,
the vast
meaning
and
a day
intricate
on
network
55
that we know
Cancri
as the
is
cosmic
only
web
18 Earth
will
hours
undergo
long
a dramatic
because it's
transformation.
tidally locked.
In the
One
future,
side of the planet is
Quipu,
always
along with other
facing
massive
its star,
structures like
while
it,
the other side
will
remains
become
in
more and more
perpetual
isolated.
darkness.
The
Temperatures
distances
on the
between
day
galaxy
side soar
clusters
to
will
over
continue to
2,000
increase
degrees
as
Celsius,
dark energy accelerates the expansion of space
3,632
itself.
degrees Fahrenheit.
Over billions of years,
while the night
the
side remains
interconnections
much colder,
between structures will
with its
weaken,
molten
stretching
surface and
thinner
diamond-like
until they eventually
composition.
break apart.
55
We must
Cancri
pause
is a
for a
world
moment to
that is
appreciate
far from
just how
hospitable.
profound this
As we
cosmic
continue our
transition will
journey
be.
through these strange and
Right now,
inhospitable
the
exoplanets,
universe is a
we are
dynamic,
faced with
interconnected
questions about
system.
how planets form,
Galaxy clusters
how they
are
evolve,
surrounded by hot
and whether
gas,
life could
dark
ever
matter,
arise
and
on
galaxies,
such hostile worlds.
each influencing
The
and
discovery of
interacting with the
55
others.
Cancri and
Over
other
time,
planets
however,
like it
these forces will
challenges
slowly
our
become
understanding of
irrelevant
the
in a
processes
universe
that govern
dominated
planet
by
formation.
dark energy.
How did
and
a
the structure
planet
of the
so rich in
universe will
carbon
inevitably
form so
unravel.
close to
This
its
process
star?
won't
How
be
did
immediate,
it end up with a
nor will it be
composition
violent.
so different from
In
anything
fact,
we find
it
in
will
our
be a
own
slow,
solar system?
almost imperceptible
In addition to
transition.
these strange planets,
For us,
we must also
here in the
consider the
present,
role of
it might seem
planetary
almost
atmospheres.
impossible to imagine
Many of
how
the
the
planets we've
universe could
discovered
eventually
so
become
far have
isolated
atmospheres
and
that are
empty.
completely
But
unlike
that's the
anything
reality
we
of
experience
cosmic
here on
evolution.
Earth. The grand
Some
story of the
exoplanets
universe,
like
HD
a
189,
story of starbirth,
733b,
galaxy
experience
mergers,
winds
and the
so
endless
strong
cycle of
that they
creation
can carry molten
will one
glass
day reach
particles
its end,
at speeds
leaving
of up to
behind nothing but
7,000
a
kilometers
vast
per
expanding
h,
emptiness.
4,350
The last stars will
miles
burn
per
out,
hour.
leaving only the
9b
dark remnants of
experience
galaxies
surface
and black
temperatures
holes
that are
to
hotter than
populate the
some
universe.
stars,
In
causing
this
their
distant
atmospheres
future,
to literally
structures
boil
like
away
Quipu
into space.
will be ancient,
One
and their
particularly
connections will have
fascinating
frayed
planet,
and snapped over
Kepler,
time. No longer will they be
452b,
part of the grand
is often
interconnected
referred
cosmic
to
web,
as
but rather
Earth
isolated
2.0
remnants,
inches,
just one part
because
of
of
the
its
cold and
resemblance
silent
to
universe.
Earth.
Beyond
Kepler,
Quipu, the cosmic isolation
is
the
located
isolation
in
of
the habitable
Quipu
zone
and
of
other
its
large-scale
star,
structures,
meaning it's at the right
signals a
distance
broader
to support
cosmic
liquid
trend.
water,
The expansion of
a
the
key
universe
ingredient
is
for life
inevitable
as we know it.
Dark energy,
It's also
which is
about
currently
1.5
causing the
times
acceleration
the
of
size
the
Earth,
universe's
which
expansion,
puts it in the
will
category of
continue to
super
push
Earths.
galaxies farther
But while
and
it might
farther
seem
apart.
like an ideal
This
candidate
phenomenon
for life,
is known as the heat death
scientists
of the
have raised
universe,
concerns about the
a state in which
possibility
the
that
universe
Kepler
reaches a temperature
452b
close
is
to
headed
absolute
down the
zero,
same path as
and
Venus.
all stars burn
As its
out.
star ages,
Quipu,
it
as
may
it drifts
eventually
apart, experience
will
a runaway
eventually
greenhouse
become a
effect,
cosmic curiosity.
causing the planet to lose its
For us,
oceans
it
and
is an
become an
awe-inspiring
inhospitable
testament
world.
to the
Each of these
universe's
planets
power
and the forces that brought it into being.
76b,
But in the far
55
future,
Cancri
it will be a
A,
fading structure,
HD189,
isolated in an ever-expanding void.
733b,
The cosmic web itself,
and Kepler,
once teeming with
452b,
galaxies and clusters
represents
connected by
a
the
unique
gravitational
chapter
pull
in the
of
story
dark
of
matter,
planetary
will gradually
exploration.
decay.
They are
The
just a
voids
few
between
of
these
the clusters
thousands
will
of
expand
exoplanets that have been
in the
discovered
filaments
in
of
the
dark
past few
matter that
decades,
once held the structure
and
together
they all
will be
highlight the
stretched
incredible
too far to
variety
remain
of
intact.
worlds that exist
What makes
beyond
this
our
fate of
solar
Quipu
system.
and the cosmic
While
web
some
so
of these
remarkable,
planets are
the
inhospitable,
sheer longevity
others
of the
show
process
promise
for
for
harboring
the
life,
universe will
or at
continue
least
to
provide
expand
clues
for
about
billions
how
of
planets
years,
evolve
and these
over
vast
time.
structures will
Our
continue
understanding
to
of
evolve
exoplanets
slowly.
is still
However,
in its infancy,
this is a gradual
and as our
process,
technology
one that
improves,
occurs on
we will
timescales
continue
far
to make
beyond
incredible
human comprehension.
discoveries.
The universe
The role
is
of black
vast,
holes in the
and we have
distant
only
future.
just begun
These
to explore
behemoths
it.
are found
But
at the
each new
centers of nearly
discovery
all
brings
large
us closer
galaxies,
to answering
including
some of
our
the
own
biggest
Milky Way.
questions we have about
Black
the
holes,
cosmos.
particularly
Questions about the
supermassive
origins
black
of
holes,
life,
are some of
the
the most
nature of
mysterious
planets,
and extreme
and the
objects in
potential
the
for
universe.
life beyond
They
Earth.
contain
The
millions
universe,
to billions
as we
of
are
times
beginning
the mass
to
of the
learn,
sun,
is far
compressed
stranger
into
and
regions
more
smaller
complex
than our
than
solar
we
system.
ever imagined.
While black holes
So
are
what
known
will
for
we
their
find
intense
next?
gravitational
What
pull,
other strange
they are
and
not entirely
fascinating
passive.
worlds are out there,
In fact,
waiting
they
to
are
be
capable of
discovered?
generating some of the
Only
most
time will
energetic
tell,
phenomena in the
but
universe.
one thing is for sure:
For example,
the journey has
active
only
galactic
just begun.
nuclei, as we venture
AGN,
deeper into the
are powered
cosmos,
by the
the
accretion
more we
disks of
uncover,
matter
the
falling
more
into
we
a black
realize
hole.
just how bizarre
As this
and
matter spirals
incomprehensible
in,
the
it
universe
heats up to
truly
millions
is.
of degrees,
From planets that
emitting
rain
intense
molten
radiation,
metal to
some black
worlds where the
holes
very
also
laws of
shoot out
physics
jets
seem
of
to bend and
particles
break.
traveling at nearly the
The
speed of
universe
light,
has a wealth of
creating
mysteries
relativistic
waiting
jets.
to be unraveled.
However, the
Let's
ultimate
begin
fate
our
of these
exploration
supermassive black
with
holes is tied to the fate of the
WASP
universe itself.
12b.
As the universe
a planet
expands
located
and
about
galaxies drift
1,400
apart, these
light
black
years
holes
from
will
Earth,
become increasingly
known as a hot
isolated,
Jupiter,
much like
this
the rest
massive
of the
gas
universe's
giant
structures.
orbits so
Without
close to its
galaxies to
star
fuel their
that it
growth,
is slowly being
these black holes
consumed.
will begin to fade over
With
time.
the temperature
Through a
soaring
process
above
known as Hawking
2,500
radiation,
degrees
black
Celsius,
holes slowly lose mass and
4,500
energy,
degrees
eventually
Fahrenheit.
evaporating
It's
completely
one of the hottest
after an unimaginable
exoplanets
amount of
ever
time,
discovered.
on the order of trillions of
WASP.
years. Before they eventually
12B's
vanish,
proximity to its
supermassive black
parent
holes
star
will play a crucial
results
role
in
in the
extreme
final
tidal
stages
forces,
of the universe's evolution,
causing the planet
in the
to
later
stretch
stages
and
of galaxy
distort,
cluster evolution,
giving it a bloated,
the activity from
egg-like
black holes
shape.
will likely
Over time,
stabilize
these
the surrounding
forces are
clusters.
tearing the
This
planet
will ensure
apart,
that the last
and in a
vestiges
few
of
million
activity
years
in the
it may no
universe are
longer
dominated
exist,
by these
leaving nothing
supermassive
but dust
objects.
and gas in space.
But this activity
But the
will
destruction
gradually
of
subside,
WASP,
marking the beginning of the
12b
universe's
doesn't
final
end
stage,
there.
the gradual
planet is so
dissolution
close
of the
to its
cosmic
star
web.
When we talk
completes
about
an
the
orbit
dissolution
in
of the
just
cosmic web,
1.1
we must
days.
consider that this process
To put
isn't
this into
sudden.
perspective,
It will unfold
Earth
over
takes
billions of years.
365 days to
Quipu,
orbit the
in all
sun,
its
so
grandeur, will eventually
WASP,
become part of the
12B's
ever-expanding
year
void
is
that will
shorter
dominate
than
the
an
universe
Earth
in the
day.
distant future.
Its extreme
dark
heat
energy
and
that now
gravitational
accelerates
pull
the
cause
expansion
the atmosphere
will
to
eventually
spill off into
overpower the
space,
gravitational forces
leading to
that
an
hold these
ongoing
structures
loss
together.
of mass.
As this
It's
happens,
a planet on the verge
galaxies
of its
will
own
drift
destruction,
apart,
and
a
the
slow,
filaments of dark
agonizing
matter that once
death
connected
fueled
them
by
will
the
stretch
stars'
so
relentless
far
pull.
that they will snap,
However,
leaving behind
despite its
isolated
inhospitable
remnants
conditions,
of the cosmic web.
WASP,
At that point, the
12b
universe will have
is of
transitioned
great
from a
interest
highly
to
structured
scientists.
and connected
By
network of
studying the
galaxies
planet's
to a
atmosphere,
lonely,
researchers are
fragmented
able to
space
gather
filled
data
only
about
with
how
black
planetary
holes and cold
atmospheres
remnants,
evolve and how
the
they
vastness of
interact
the
with their
universe will
parent
feel
stars.
even more pronounced
In the case of
as the cosmic
WASP
structures fade into the distance,
12b,
leaving
scientists
only
have
dark
found that its
remnants to tell the
atmosphere is
tale
composed of
what
gases
once
like
was.
carbon monoxide.
But even in its final
sodium,
stages,
and
the universe
titanium
will
oxide.
still hold its
These
secrets,
compounds are not
as galaxies
typically
and
found in
clusters
Earth's
drift apart,
atmosphere,
and the cosmic
and
web
their
breaks
presence
down.
could help
The
scientists
story
learn
of the
more
universe's
about how
formation
other
and
planets
evolution
might support or
will remain
lack
written
life.
in the fabric
While
of space
WASP,
itself. The universe, like
12b,
Quipu,
is being
will
torn
leave behind
apart
traces
by
of
its
great
star,
cosmic journey.
Kepler.
It will
0b
remind us that
offers a
even in
glimpse into the
isolation,
future
the
we
remnants
hope
of
never
this
to
vast network of
experience.
matter and energy
Once considered
were
a
once
hot
connected
Jupiter,
in ways that defy
like
comprehension.
WASP,
The final understanding of
12b,
cosmic evolution,
Kepler,
as we think about the far
70b
future and
is
the
now a
eventual
barren,
fate of
lifeless
Quipu,
rock,
the cosmic
a
web,
planet that was
and
once
the
a
universe
massive
itself.
gas giant,
We are
but has
reminded
since
of the
undergone an
scale of
extraordinary
extraordinary transformation.
The universe is
Orbiting a
not only
star
vast
similar
in its
to our
spatial
sun,
dimensions, but also in the
Kepler
timescales over which it operates.
70b once
The
had an
forces that govern the
atmosphere and
universe are
oceans,
slow,
but
working
these were
over
stripped
billions of
away over
years to
millions
shape
of
galaxies,
years as the
stars,
star
and
evolved
structures
into a
like
red
Quipu.
giant.
Yet,
Today,
even
the
as these
planet's
forces
surface is an
continue to act,
inhospitable
we are
wasteland,
left with a universe
scorched
that
by
is,
the
in the
intense
grand
heat
scheme
of the
of things,
star's dying
temporary.
phases. Kepler The eternal struggle between gravity and dark energy will eventually come to a close, and the universe will find its final resting place.
As our sun
For now,
enters its
however,
red
we are
giant
still
phase,
part of an
it will
active
expand
and evolving
and
cosmos.
swallow the inner planets.
The discovery of
including
structures
Mercury,
like Quipu
Venus,
teaches us about the
potentially
immensity of the
Earth.
universe
In the
and
distant
the forces
future,
that shape it.
Earth could become
It shows
just
us
like
that even the
Kepler.
most grand and seemingly permanent
70b,
structures
a
are
lifeless,
temporary in the face
burned-out
of cosmic
shell
time.
of a once
The very
vibrant
nature
world.
of the universe is one
But
of
it's not
constant
just the
change,
future of our own
and
planet
Quipu
that's in
is simply
question.
one of many
Kepler
cosmic structures
70b
that will
shows us
eventually
that no
fade,
planet is immune
making
to the
room for
inevitable
new
process of
discoveries
stellar
and
evolution.
understandings. But we will always
Even
have
the
the
most
knowledge
promising
that
worlds
Quipu,
can
along
eventually
with
be
its dark
consumed
matter,
by the stars
gas
that gave
filaments,
them life.
and galaxy clusters,
In contrast,
was once a
we turn
shining
our gaze
example
to a
of the
planet
universe's
that has
dynamic
had an
forces.
entirely different
And
fate.
even as these forces fade and break
Trappist,
apart, they
one,
will leave us with a legacy
star
of
system
understanding
located
and
just
discovery,
40 light years
a
away
reminder
from
of
Earth,
just how
is
small
home to
and
7
yet how
Earth-sized
profound
planets.
our places in the
These
grand
planets
scheme
orbit
of the
a
cosmos.
cool, dim
The
star,
nature of cosmic time,
making them some of
the
the
big
best
picture of the
candidates for
universe's
hosting life
evolution,
outside
as we
our
stretch
solar
our
system.
minds to the farthest
Trappist,
reaches of cosmic time.
one has captured
We are
the
forced to
imagination of
confront
astronomers
something
and the
deeply
public
humbling.
alike.
The
As
history
its
of the
planets
universe
reside
spans
in
what's known as the
13.8
habitable
billion
zone,
years,
the
a
region
duration
around a
far
star
beyond
where
any
conditions
human
might be right for
experience,
liquid water
and the
to
forces
exist.
shaping it have
What
played
makes
out
Trappist
across immense timescales.
one particularly intriguing
Quipu,
is that
like
several of
all
its
other
planets are in
structures in the
synchronous
universe,
orbit with one
is
another,
only one chapter
meaning
in
they
an
all
ongoing
rotate
story,
at the same
story
rate
of the
and are
universe's
likely
birth,
tidally locked to
evolution,
their star.
and inevitable
This could create
decline
unique
is so
conditions
vast
for life
that it is
as
almost
one side of the
impossible
planet
to comprehend.
might be perpetually
When we
bathed
zoom
in
out to the
sunlight,
largest scales,
while the other
we can
side
see that the
remains in
universe
eternal
is still in the
darkness.
midst of its cosmic
In addition,
evolution.
the possibility that
Quipu
these
represents
planets
a
have
snapshot of
atmospheres
the
and
universe's
surface
middle
conditions
period,
suitable for
a
life
structure that
makes
formed over
Trappist
billions of
one
years and will
of
continue
the
to
most
evolve,
exciting
albeit slowly,
exoplanetary systems
for billions
discovered
more.
to date.
But even Quipu's dramatic
Trappist,
size will eventually be
one's
reduced
planet
to something
not
less
without their
spectacular,
challenges,
as dark
The
energy
star
accelerates
itself
the
is a red
expansion of the
dwarf,
universe. A type
In
of
some
star that is
sense,
much
the end of
smaller and
Quipu
cooler
and other
than our
large-scale
sun.
structures
Red
may seem
dwarfs
like
are
the end
known
of the
for their
story,
flare activity,
but in another deeper
and
way,
Trappist,
it's
one's
merely another
star
chapter,
is no exception.
one that ends
These
only to
flares
make
could
way
strip
for the
away
next
the
phase
atmospheres
in
of
cosmic
any planets
evolution.
orbiting
The
too
ultimate fate
closely,
of the universe will
making
be
it
marked
difficult
by
for
the
life to
isolation of
thrive.
structures
However,
like Quipu,
even
the
with these
dissipation
challenges,
of galaxy clusters,
Trappist
one
one
offers us a
eventual
tantalizing
disappearance of
glimpse
stars
into the
But as
possibility
this
of
new
life
era
beyond Earth,
unfolds,
reminding
we
us
must
that
reflect
the
on how the
universe
very
is
nature
full
of
of time,
potential
is
waiting to be
intertwined with the
explored.
cosmic
The
forces
discovery
that
of
have created
systems like
this
Trappist
expansive and
one also
complex
challenges
structure.
our
The
understanding
unanswered
of how
questions about
life
dark
might
matter
arise.
and dark energy,
Scientists
despite the
have long
progress we've
assumed
made in
that
understanding
life
the
requires
large-scale
planets
structure
with
of the
specific
universe,
conditions,
dark
like a
matter and
stable
dark energy
climate,
remain two of the
liquid
most
water,
perplexing mysteries
and
in
an
modern
atmosphere.
physics.
But with each
While
new
we have gathered
discovery, it
substantial
becomes
evidence
clear
for the
that life
existence
could
of both,
exist in forms
we
we
still
haven't
don't
yet
fully
imagined,
understand what
in
they are,
environments
how
far
they work,
harsher than we
or
would have
why
thought
they seem to
possible.
dominate the universe's
If life
behavior.
can exist on a planet
Dark
like
matter
Trappist,
is particularly
1e,
elusive. While
which
we
is
can
constantly
detect its
bombarded by
gravitational
radiation
influence on
from its
visible
star,
matter, such as
then
galaxies,
who's to say what
galaxy
other kinds
clusters,
of life might
and
exist
cosmic
on
structures
planets
like
with even
Quipu,
more
we
extreme
have no
conditions?
direct means of
In our
detecting
search
it.
for life,
We know
we
it's
cannot
there because we
ignore the
see the
potential that
gravitational
exists
pull
on
it exerts,
exoplanets orbiting
bending
stars
light and
far
influencing the
outside our
motion of
solar
galaxies
system.
in ways that
Planets
ordinary
like
matter cannot
HD
explain.
403077G,
It's the invisible
a
scaffolding
super
that
Earth
holds the
located
cosmic web
42
together,
light-years from
yet it
Earth,
refuses
offer
to show itself.
tantalizing
The
possibilities.
most widely accepted
This planet
theory
resides
is that dark
in
matter
the habitable
consists
zone
of
of
weakly
its star,
interacting massive
a
particles,
G-type star
WIMPs,
similar to our sun,
particles that
and it is
interact via
considered
gravity,
one of the best
and
candidates
possibly
for
the
finding
weak nuclear
alien
force,
life.
but do not
HD
emit light or
403077G
interact electromagnetically.
is about 7
Yet,
times the
despite
mass of
years
Earth,
of searching,
making it
we
a
have not
super
yet
Earth,
detected these
a
particles
type
directly.
of planet that is more massive
Experiments
than Earth,
have been
but
conducted,
still potentially
both
capable of
underground and in
supporting liquid
space,
water
to
and
try and
even
spot
life.
dark matter.
What makes
but it
HD
remains stubbornly hidden.
403077G
In many ways,
so
dark
intriguing
matter is more of an
is that it
enigma than
orbits
ever,
its star
and its
at
discovery
just the right
could
distance
open up
to
entirely
maintain a
new
temperature
realms of
that could
understanding in
support life.
physics.
Unlike
Meanwhile,
planets
dark
like
energy,
Venus, which are
which is
too close
responsible
to
for
their
the
stars,
accelerating
or
expansion
Mars,
of the
which
universe,
is too far,
is even more mysterious.
HD
Dark energy makes up about
403077G
is in the sweet
68%
spot
of the
where liquid
universe's
water
energy
could
content,
exist on its surface.
but we still don't know
If
what
there
it
is water
actually
on the
is.
planet,
What we
it
do
could
know is
provide
that
the
dark
necessary
energy
conditions
exerts a
for life to
repulsive
form.
force that accelerates
But as
the
with all
expansion of
exoplanet
space.
discoveries,
This
there are
force has
many
caused the cosmic
unknowns.
web to stretch ever further.
We cannot yet
and
say
in the
with
long run
certainty
it will lead to the
whether
separation of galaxies and the decay of large
has an
structures
atmosphere,
like Quipu.
let alone
The
whether it
exact
could
nature
support
of dark
life as we
energy
know it.
remains one of the
These
most
planets,
profound questions in cosmology.
WASP,
Is it a constant force?
as first
Kepler,
proposed by Einstein's
7
cosmological
OB,
constant?
TRAPPIST,
Or is it something that
1,
changes over
and
time?
HD
A substance we now refer to as
40307G
quintessence
represent
is
the
dark
incredible
energy, a
diversity of
manifestation of
worlds
something much
that
more
exist
fundamental,
beyond our own
like
solar
extra
system.
dimensions.
Some
or
are
unknown
inhospitable,
physical principles.
others might support
While we
life,
know that dark
and
energy
some may
is
have
causing
already
the
gone through the
expansion of the
stages of
universe to
destruction
accelerate
and rebirth.
the origin of this
But no
force
matter what the fate
and
of
how
each
it will
planet,
behave in the distant
they
future
all share
is
one
still
thing in
unknown.
common.
These mysteries
They remind
represent
us
some
that
of the
the
most
universe
exciting
is full of
frontiers in modern
surprises,
science,
and we are
the
just
discovery
beginning
of
to
dark
scratch
matter
the surface
and dark
of
energy
what is out there.
could
As we
revolutionize
continue
our
our
understanding of the
exploration,
universe.
we will
and
encounter
rewrite
even
the
more
fundamental
strange and
laws of
mysterious
physics.
worlds.
But for now,
each
they
one
remain
challenging
two of the
our
greatest
understanding of
unknowns
the
in the
cosmos.
cosmos.
The
The
journey
cosmic
to
web's role
understand
in
these
understanding
distant
life
planets
and
is
existence
just beginning.
as we contemplate
with
the
each
immensity
new
of
discovery,
Quipu,
we
the
edge
cosmic
closer
web,
to
and the
answering the
mysterious
age-old
forces of dark
question,
energy and dark
are
matter.
we alone
We are
in the
reminded of
universe?
our place in this
Only
vast,
time will tell.
incomprehensible universe.
As our
Our
understanding of the
cosmos
universe
expands,
is not just about
we are
stars and
confronted with
galaxies,
more than just the
it's
potential
about
for life in distant
our
systems.
life, our
We are faced
understanding,
with worlds
our
that challenge
place
the very
in the
fabric
grand
of our
scheme of
understanding
things.
of physics
The search
and
for
reality.
extraterrestrial life
The
has been one
universe
of the most
isn't just
human
a collection
endeavors
of
of the
stars
past
and
century.
planets. It's
And
a
yet,
cosmic
despite the
theater
growing
where
number
the
of
laws of
exoplanets
nature
are
and the
constantly
discovery of
being
potentially
pushed to their
habitable
limits,
worlds,
take
we still haven't found
WASP,
concrete evidence of life beyond
76b,
Earth.
for instance.
The vastness of the
A
universe
planet
offers
that
hope and
defies
melancholy
everything
in
we know
equal
about
measure.
atmospheric
We have to ask
conditions.
ourselves,
Located
if the
about
universe is so full of stars
640
and
light
planets,
years away,
why haven't we found any signs of life
WASP
elsewhere?
76b
Are we truly
is a
alone,
massive
or
gas
is life
giant.
simply so
But what sets it
isolated by
apart
the
is its
enormous
extreme
distances of space
conditions.
that we can never
The planet's
communicate?
proximity to its
The
parent
answer may
star
lie
makes
in
it
the
one of the
scale of the
hottest
cosmic
exoplanets
web,
ever
the vast
discovered,
distances between
with temperatures
galaxies,
soaring
the
to over
isolation of cosmic
2,400 degrees
structures,
Celsius,
and the immense time
But
it
what
takes
really
for
makes
light to travel
WASP
from one place to another, all
76b
pose
stand
barriers
out
to
is the
communication and
possibility that it
travel.
rains
Even if
molten
advanced
iron.
civilizations
The extreme
existed in
heat on the
distant
planet's
galaxies,
dayside
the
evaporates
time lag
metal
and
into the
distance
atmosphere,
between them
which
and
then
us may be
condenses and falls
insurmountable.
back down as
Perhaps we
liquid
live in
iron
an
on the
isolated
cooler
corner
night
of the
side
universe,
planet,
surrounded
It's a
by other
scenario
civilizations
straight out
that
of
are
a
equally
science
separated
fiction
by these
nightmare.
vast distances.
Yet here it is.
Maybe the
An
universe is
actual
teeming
world
with
where
life,
molten metal
but the
could
barrier
fall
of
from the
space and
sky.
time makes meaningful
WASP
communication or travel
76b's,
impossible.
If
Life
strange
exists
weather
elsewhere,
patterns don't
it's
stop
likely
at iron
that it's
rain,
just as isolated
due
as
to its
we
close
are.
orbit
Making
around
the
its
study
star,
of the cosmic
the
web
planet is
not
not
just
just
about
about
understanding
understanding
structures,
meaning
but
one
about
side
contemplating
always
faces
faces
the
the
star,
itself,
while the
the
other
vast
remains
web
in
of
perpetual
galaxies,
darkness.
clusters, and filaments
This creates a
is not
temperature
just the
difference
physical
so
structure of
extreme
the
that
universe,
winds blow at
it's the
speeds
framework
of
of
over
existence,
11,000
the
miles per
intricate
hour,
pattern that gives
18,000
rise to
kilometers
everything,
per age,
from stars to
between the
life,
planet's
from
scorching
galaxies to
dayside
dark matter,
and its freezing
the final
night
legacy
side.
of Quipu.
These winds
A
carry
monument
molten
to the
metal
cosmos
through the
Quipu,
planet's atmosphere,
like all cosmic
contributing
structures,
to the
is
bizarre
destined
and
to
violent
fade and
conditions
eventually
on the
become a
surface.
relic in the far future.
If you were to find
Its
yourself
once
on the
dominant
day
role in
side
the
of
cosmic web
WASP
will be reduced to that of a
76b,
distant,
you'd be
isolated
facing
remnant.
temperatures
But
that
its
could melt
legacy will
metals and
endure,
rocks alike,
not just
and
in
the
the
winds would
cold
be so
remnants of
intense
its galaxy
that they would
clusters,
rip through
but in the
anything in
knowledge
their
we have
path.
gained
But
from
even
studying
stranger
it.
than the molten
Quipu
rain and
represents
winds
the
is
pinnacle
the
of
recent
cosmic
discovery of
organization,
glories,
the largest
a rare
coherent
phenomenon
structure
that had never
we have
before
yet
been
discovered
observed
in the
outside of
observable
our solar
universe.
system.
And yet,
These
as we
brilliant
consider its
circular
eventual
rings of light
isolation,
are
we must
usually
also
seen from
recognize
Earth during
that Quipu
specific
is part of a
atmospheric
larger
conditions.
story. On
The entire
WSP
universe is
76b,
interconnected.
however,
Each
they
galaxy,
appear during the
each star,
transition
and
between
each
the
piece
day
of
and
matter
night
playing
signs
a
of the
role
planet.
in the cosmic
The light
narrative.
appears to be
Quipu
reflected
is just
of
one
clouds
part made
of
of
a much
spherical
larger
droplets
cosmic
of
evolution,
material, likely
and even
iron
though it
or
will
some other
eventually
heavy
fade
element.
into isolation,
The discovery of these
it will leave
glories
behind
gives scientists
invaluable
new
clues
insight into
to
the planet's
understanding the
atmosphere
forces
that
and the
have shaped
possibility
the
that there
universe.
could be even
The
more
future of
mysterious
cosmic
phenomena
exploration,
to uncover.
while Quipu may
The
one
fact
day
that
be a
such a
distant
phenomenon
memory,
was observed
the
on a planet
exploration
so
of the
far from
universe is
Earth
far from
shows
over.
just how much
The
we
next
still have to
generations of
learn about the
telescopes and
vast
space
and
missions
strange
will
worlds
push
that
our
inhabit
understanding even
universe.
further,
Yet for all the
helping us to
wonders and
understand
odd
oddities of
structures that
planets
are even
like
larger than
WASP,
Quipu, or revealing
76b,
aspects of the
cosmic web
there are
we haven't
worlds
yet
that are
dreamed
so
of.
different from
The
Earth
dark energy
that
and
they
dark
push the
matter that
boundaries
shape
of
the
our
universe
imagination
are still
55
largely unknown,
Cancri,
and the future
also
of
known as
cosmic
Diamond
discovery
Planet,
will be one
is
of
one such
unraveling these
world.
mysteries.
Located
In this
around
sense,
40
the
light
search
years
for
away in
knowledge
the
about the
Cancer
universe is a
constellation,
never-ending
this
journey,
planet is a super
one that will
Earth,
continue
meaning
long
it's
after
more
we've
massive
moved
than
beyond
Earth,
the
but
mysteries
not
of
quite as
Quipu.
large as
The
Uranus or
exploration of the
Neptune.
universe is
What
not
makes
just about
55
discovering
Cancri
new
truly
structures.
unique, however,
It's about
is its
discovering our
composition.
place within this vast,
It is believed to be
expanding
made
cosmos.
largely of carbon,
As we study the cosmic
which,
web,
under the
we are not
intense
just
pressure
learning
and
about
heat from
distant
its parent
galaxies and
star,
stars.
has
We are
crystallized
learning
into
about
diamond.
ourselves,
55
about the
Cancri
forces that
orbits its
created us,
star,
the structures
55
that
Cancri
sustain us,
A,
and
a
the
yellow
future we are
orange
headed
star
toward,
similar to our
the
sun,
beginning of the end,
in just 18
the slow
hours,
fade into the
an
cosmic
incredibly
night
short
as we contemplate the
year.
immense
The planet is
structures
so
like
close to
Quipu,
its star,
it becomes
it
impossible to
experiences
ignore the
extreme
fact
heat,
that every grand
with
entity
surface
in the
temperatures
universe,
that could reach up
no
to
matter how
2000
magnificent,
degrees
is
Celsius,
bound by the inexorable march of time.
3632
Every star,
degrees
every
Fahrenheit.
galaxy, every
The intense
cluster,
heat
and every
combined with
cosmic
the high
structure
pressure
is slowly
has
moving
caused the
toward a
planet's
shared
carbon-rich
destiny,
composition to
entropy,
crystallize
the
into
gradual decay
diamond.
and breakdown
If you
of
were to
order
stand on the
into
surface
chaos.
of 55
Though
Cancri,
Quipu is one of the
which,
largest
for the
coherent
record, would be
structures we have ever
impossible due to the
discovered,
extreme
it too is
conditions,
bound by the same
you would be
fundamental
surrounded
laws
by a
that govern the
landscape
rest of the
glittering with
universe.
diamonds.
The current rate
But
of
this
cosmic
isn't a paradise
expansion
made of
driven by
precious
the force of
stones.
dark energy
It's a world of
means that in the
crushing
distant
heat
future,
and unrelenting
even
pressure,
Quipu, with
where
all its
even the hardest
complexity and
materials
grandeur,
can barely
will experience
survive.
a slow,
Scientists
inevitable
are fascinated
dissolution.
by 55
The
Cancri
clusters that form
because it
Quipu
offers a
will
glimpse
drift
into a
farther apart,
completely different
their
type of
connections
planetary
slowly
formation.
fading as the space
Unlike
between
Earth,
them stretches
which
to
formed from rocky
unimaginable
materials,
distances.
55
Eventually,
Cancri's
Quipu,
formation likely
once a
involved
massive
process that
interconnection of
created
galaxy
a planet
clusters,
dominated by
will become a
carbon
series
and
of lonely
diamonds.
islands.
It also raises
Isolated
the
in a
intriguing
vast,
possibility
empty
that there could be
universe.
other
The
diamond
vastness of
planets
time,
out there,
the cosmic
waiting to be
timescales we're
discovered.
talking about,
The discovery
is
of
one of the
these
most
unusual
humbling
worlds
aspects of this
challenges our
process.
assumptions about
When we
what
look at the
planets
larger
can look
structures like
and
Quipu,
how they can
it can be
form,
difficult to
and it shows
comprehend
just
that
how
their current
varied
state
and
of
diverse the
interconnectedness
universe
is
truly
only a
is.
fleeting
But as we
moment
venture
in the
farther out
universe's
into the
long
cosmos,
cosmic
we begin
history.
to encounter
Billions
even
of
more
years from now,
mysterious and
structures like
potentially
Quipu will have
hostile
long
worlds.
faded, and the universe
One
will
such
be a
planet
vastly
is
different place.
HD 189.
But even as we watch the universe shrink,
733b,
the
a
changes
world
that
that
take
is
place
so
in these
violent
final
and chaotic
phases
that it
are
seems like
deeply
something out of
meaningful
a
for our understanding
post-apocalyptic
of cosmic
science fiction
evolution.
novel.
The future of
Located
Quipu
about
and all
63
structures
light
like
years
it
away,
holds the key
HD
to understanding
189.
not only the fate of the universe,
733b
but
is a
also
hot
the forces
Jupiter,
that have governed its
meaning
formation
it is a
and
massive
evolution
gas
since
giant
the very
orbiting
beginning.
very close
Cosmic
to its star.
recess, the
The planet's
expansion and the
surface
great
temperature
isolation.
is more than 1,000
As we
degrees
progress
Celsius,
toward the future,
1,832
it's essential to consider
degrees
the role of
Fahrenheit,
dark
and its
energy in
winds
the
are
grand
so
scheme of the
intense that
universe's
they can reach
evolution.
speeds
Dark
of up to
energy is a mysterious,
5,400
repulsive
miles
force
per hour,
that is accelerating
faster
the
than the
expansion
speed
of
of
the
sound.
universe,
The
causing
planet's
galaxies
atmosphere is
and other
composed of
structures to
toxic
move
gases,
further away from each
and
other
the clouds
at
are
an
made of
increasing
molten
rate.
glass.
As dark
which is
energy
carried
continues
across
to
the
dominate,
planet by the
it
howling
will ultimately
winds.
lead to
The most
dissolution
terrifying
of
part of
structures like
HD
Quipu.
189
The cosmic web,
733b, however,
once a vibrant
is the
network
rain.
of interconnected
Unlike
galaxies
Earth's
and
gentle
clusters,
showers,
will unravel.
the rain on this
Space
planet is
itself
made
will
of
stretch
molten
and
glass.
expand.
As the planet's
Separating the
high
galaxies
winds
and
whip the
clusters
glass
that
particles
were once
across
held
the
together by
surface,
gravity
they
and dark
create a
matter.
deadly
This
storm
process
of
will
sharp,
occur gradually
burning
over
glass
billions of
shards.
years.
If you were
But
to
it will
find
eventually
yourself
reach
on
a point
HD
where the connections
189
between galaxy clusters are
733b,
so weak
again
that they
a
will
near
break
impossible
apart
scenario,
completely.
you
Even
would be
Quipu,
subjected to
the
intense
largest known
heat,
coherent
powerful
structure in the
winds,
observable
and constant
universe,
showers of
will be
molten
nothing
glass.
more than a distant
It's
memory,
a planet where
a
survival
faint
is
echo of a
impossible,
universe that
and
once
it's a
was.
chilling reminder
This
of the
cosmic
hostile
expansion will
environments
make it
that exist in the
increasingly
universe.
difficult to study
What makes
or
HD
even observe
189
these structures.
733b
As galaxies recede
even
faster
more
than the speed of
fascinating
light,
is
light
that it
from
is one of
distant
the
objects
best
will
studied
never reach us.
exoplanets.
Will be left in a
And it has
state of
provided
cosmic isolation,
scientists with valuable
where the objects
data
we once
about the
observed
behavior
and studied
of hot
will
Jupiters
fade beyond
by
our
studying
reach,
its
never to be
atmosphere
seen
and weather
again.
patterns.
As this process
Astronomers can
unfolds,
learn more
we are
about the
faced with
processes
the
that
paradox of
govern
time.
these extreme
The
worlds.
universe, which is
Despite
constantly
its
evolving,
inhospitable
will
conditions,
eventually reach a point of
HD
stillness,
189,
where the once dynamic structures we have come
is
to know
teaching
and
us more
study
about the
will
violent
no longer
forces that
exist
shape
in the
planets,
same way.
and
But
how
even
they
though the
interact
cosmic
with
web
their
will
parent
fade,
stars.
its legacy will
These
remain.
planets,
Every
where
discovery we
CSP,
make about these immense structures, whether it's
76b,
Quipu or
55
something even
Cancri,
larger,
HD
adds to our
189,
understanding of the universe's
733b,
history and our
represent
place
just a
within
few
it.
of the countless
death of
exoplanets
stars,
that exist
the long
beyond our
road to the
solar
cosmic
system.
fade.
Some
The
of
most
these
intimate
worlds
connection
are
we have with the
inhospitable.
universe is
Some
our
are filled
relationship
with
with
strange
stars.
and deadly
Stars are
phenomena.
the beacons of light
But all of
that
them are
illuminate
unique
the
in
night
their own
sky.
way. Their births,
They
lives,
challenge
and
our
deaths
understanding of
define
the
the
universe
cosmic cycles
and
of
push
matter
the boundaries
and
of
energy.
what we thought was possible.
Stars create the
As we
elements that
continue
make up
to
the world
explore the
around
cosmos,
us, from
we are
carbon
sure
and
to uncover
oxygen
even
to the
more
very
bizarre
atoms
and
in our
terrifying
bodies.
worlds worlds,
But like all
each
things
one
in the
more
universe,
surprising than the
stars
last.
have their life
With each new
cycles.
discovery,
For
we
now,
are reminded of
stars
the
like our
vastness of
sun
the universe
will continue
and
to
how
burn
much
for
we have
billions
yet
of
to learn,
years,
producing
while
the
some of
energy
these
that
planets may
sustains
be
life on
inhospitable
Earth.
to
But
life as
eventually,
we know it.
all stars will
They
run out of
provide us
fuel.
with invaluable
The sun, for
information
example,
about the
is
forces
expected to
that shape
burn for another
planets
5
and the
billion years
processes that
before it
govern the
exhausts
cosmos.
its hydrogen
As
fuel
our
and
technology
expands
continues
into
to
a red
improve,
giant. We
As
will
the
be able
sun
to peer
reaches the
even
end of its
further
life,
into the depths
it will
of
engulf
space,
the inner planets,
uncovering
including
more
Earth,
mysteries
in a
and
fiery
revealing
expansion.
even more
After this
astonishing
phase, the
worlds
sun will shed
that
its outer
exist
layers,
beyond our
leaving
reach.
behind a white
As we
dwarf,
delve deeper
a
into the
small,
cosmos,
dense
we
remnant of
realize
its
that
former
our
self.
understanding of the universe
Over billions
is
of
still in
years,
its
the white
infancy.
dwarf will
The
gradually
more we
cool,
explore, the
becoming
more
an
we are
inert
confronted by
object in a
phenomena
cold,
that
dark
stretch the
universe.
boundaries
As
of our
stars
imagination
die, their
and
energy is
challenge
released in the
everything
form
we
of
think we know
supernovae,
about the laws of
spreading
nature.
heavy
With
elements
every
across
discovery,
space.
we find ourselves
These
asking
explosions
more
are the end of an
questions
era
than we
for the
can
star,
answer, but also
questions
the
that
beginning
may
of a
never
new
be
chapter
fully
in the
resolved.
cycle of matter.
But
The
the
material
material
released
released
by
by
supernovas
supernovae
pushes us
forms
forward,
the basis for
even
new
into the
stars
most
and planets.
extreme and incomprehensible
However, once the
corners of
last stars
space.
burn out,
Among the most
this cycle
astonishing
will come to an
discoveries in
end,
recent
and the
years
universe
is the
will be left
exoplanet
with nothing but black
KELT,
holes, white dwarfs,
9b,
and
a
neutron
world so
stars,
extreme that it
silent
redefines
relics
what we
of a
thought
once
was possible
vibrant
for a
universe.
planet. The death of
Located
stars
about
is a slow
670
process,
light years
spanning
away in the
billions of
constellation
years.
Cygnus,
But when it is complete, the universe will be left in a state of
9b is a
darkness
gas
and
giant
stillness.
that is the hottest
Galaxies will
known
no
exoplanet
longer
in
produce new
existence.
stars. Its surface temperature reaches
Supernovae
an
will cease,
unbelievable
and the universe will be left in a
4,300
state
degrees
of cosmic
Celsius,
recession,
7,800
when nothing new can
degrees
emerge.
Fahrenheit.
This
Which is
final
hotter than
stage of the
most
universe's
stars,
life will be
including
a
our
time
own
of
sun.
great
The
isolation
planet orbits
and
a star
cosmic
that is also
silence.
incredibly
The legacy
hot,
of Quipu
with a
and
surface
cosmic
temperature of
curiosity,
10,000
despite
Kelvin,
the eventual
nearly
dissolution
twice
of
as hot as
Quipu,
the sun.
the legacy of these cosmic structures
KELT
will live on in the
9b's
stories we tell,
extreme
and the
conditions
knowledge
are the
we have
result
gained.
of its close
The discovery of
proximity to its
Quipu
parent
and other
star,
large-scale
which it
structures
orbits
in the
every
universe
1.5
has been one of the
days.
greatest
This means
scientific
that the
achievements
planet
of
is
the modern
subjected
era.
to an immense
These
amount of
discoveries are not
radiation,
just about
heating
mapping
it
the
to
universe
temperatures that would
They're
incinerate
about
any known
understanding
material.
our place in the
The
cosmos.
atmosphere of KELT,
Even though the universe is
9b,
vast
is
and our
constantly
lives are
being
fleeting,
stripped away by the
our
intense
curiosity
heat,
and thirst
with
for knowledge
molecules
drive
like
us to
hydrogen and
explore and
helium
understand the very
evaporating into
fabric of the
space at an
universe.
alarming rate.
In a sense,
In fact,
Quipu and
the planet
cosmic
is
web
losing mass so
represent
quickly
not only
that
the
scientists
unimaginable
predict it
size
could
of
be
the
completely
universe,
evaporated
but also the
within a few
incredible
hundred
human
million
achievement
years.
of
The
understanding
conditions
that
on
scale.
KELT,
As the future
9b,
unfolds,
are so
the
hostile
universe will
that it is
continue to
impossible
evolve,
for life,
but
as
the
we
knowledge
know
we
it,
have gained
to
about
survive.
Quipu,
But
the
the
cosmic
study
web,
of this
and the
extreme
forces
planet
shaping
offers
the
a unique
universe will
opportunity
be
to
passed
understand
down.
the behavior
These
of hot
discoveries
gas
will
giants
continue to
and the
inspire
processes
future
that govern their
generations,
atmospheres,
driving scientific
the data
inquiry and
gathered from
exploration for years to
KELT,
come.
9b
And even in
could
the
help
eventual
scientists
decay of the
learn more
cosmic
about
web,
the early stages
the
of planet
curiosity that
formation
led us to
and the
discover
evolution of
Quipu
planetary
will serve as a
atmospheres in
reminder
extreme
of our deep
environments.
connection to the
It
universe
also serves
and
as
our
a
place
reminder
within
of
it.
just
As
how
time
varied and
marches on,
unpredictable
the
the
observable
universe
will begin to
While
look
some
vastly
planets may
different
harbor
from what we
life,
see today.
others are
The
so
cosmic web
inhospitable
that stretches
that
across
they
the
seem almost
observable
impossible
universe
to
will eventually
comprehend.
dissolve.
Yet, as we move
and
through
the
the
galaxy
universe, we
clusters and
encounter planets
superclusters
that
we
aren't
now
just
consider the
inhospitable,
backbone of the
they are
universe will
downright
drift farther
terrifying.
apart.
One such world
Disconnected
is
by the accelerating expansion of space. As dark energy continues to
1D,
dominate,
part
the
of a
forces
system
that
once
once
bound
bound
galaxies
galaxies
and
and
clusters
clusters
away.
together will weaken.
TRA,
And the intricate network of filaments that makes up the cosmic web will slowly
1D
stretch
is
thin,
part of a
eventually
seven-planet
snapping
system,
like frayed
all of
threads
which
in the
orbit a
wind.
small,
The
cool
death of
dwarf
stars
star.
will be one of the most
While
defining
some of the
features of
planets
this
in the
final
T
phase
are
of the
AP,
universe's evolution. Stars that are still alive
One
today,
system have been
including our
identified
own
as
sun,
potentially
will
habitable,
eventually run out of fuel.
TRAP.
As the hydrogen in their cores is
PIST.
exhausted, they will begin to
1D
expand
presents
and
a
cool,
different challenge.
entering their final
This planet
stages.
is subjected
Massive
to tidal
stars will
heating,
end their lives
which
in
is the result
supernova
of the
explosion,
gravitational pull
spreading
between
heavy
it
elements
and
across
its neighboring
space
planets.
and leaving behind
As a
remnants
result,
like black holes or
TRAP,
neutron stars. The
PIST,
smaller stars will become white
1D's
dwarfs,
surface is
slowly
constantly
cooling
shifting
and fading
with
into
massive
nothingness over
tectonic
billions of
activity
years.
occurring across
However,
the planet's surface.
long before this happens,
This could create
the birth of
violent
new
earthquakes,
stars will come to
volcanoes, and a
as the
constantly
universe
changing
ages.
landscape.
The gas needed
The
to
atmosphere
create new
of
stars will become increasingly scarce. The supply of
TISTS
raw materials for
1D
stellar
is also
formation will
likely
be
to be
depleted,
dense,
and the process
with
of
high
star
levels
birth
of
will
radiation
cease.
from the star.
The remaining
bombarding
stars will
surface.
burn for billions of years.
While it may not
but
be
eventually
the
they
extreme
too will
inferno
reach the
of
end of their life
KELT,
cycles.
9b,
nuclear fuel consumed.
TRAP,
When the last stars finally burn out,
PIST,
the universe will be
1D
left in a
is
state
still
of
an
complete
incredibly
darkness.
hostile world.
The black holes
One
that
that would be
remain
nearly
will be the final
impossible for
remnants
any
of the form of
cosmos,
life to
their
thrive
immense
on.
gravity pulling
But
in
even in the
everything
face
around
of
them.
such
But
hostile
even these
environments,
giants won't last
the
forever.
search for
Over
habitable
trillions
worlds
of years,
continues.
they will
Scientists are
evaporate
constantly
through
on the
Hawking
lookout for
radiation,
planets that
a
might
process
possess
so
the
gradual
conditions
that it will
necessary
be
for
almost
life.
impossible to detect.
Planets that lie in the
far
habitable
future,
zone,
black holes,
the region
once
around
the
a
most
star where
powerful
conditions
forces
are
in the
just
universe,
right for
will
liquid water to
disappear,
exist.
leaving only
One
empty
such
space
planet
in
is
their wake.
Kepler,
Even though the stars will have died and the
452b,
galaxies will
often
have drifted
referred to
apart,
as
there will
Earth
still be some
2.0.
remnants of the
This
universe's
super-Earth,
earlier energy.
located about
Black holes will
1,400
continue
light-years
to
away,
exist for an
is the
incredibly
closest
long
planet
time,
discovered to
and they will
date
play a
that is
crucial
similar
role
to
in the
Earth in
final
terms of
days
size,
of the universe.
temperature,
As they grow
and
more
distance
isolated,
from its star.
they will become
Kepler,
even more significant in the
452b,
universe's last
orbits its
stages,
star.
pulling
Kepler,
in whatever matter remains,
452,
stretching
once every
time and space to their
385
limits.
days.
The energy
making
released by
its
black
year
holes in
nearly
their final
identical to
moments could
ours.
be the last
It
burst
lies
of
in the
power the
habitable
universe
zone,
experiences.
where
But
temperatures are
eventually,
just
this
right
too
for
will come
liquid
to an
water
end.
to exist.
Dark
And
energy,
its size
which is
is about
responsible for the
1.5
accelerating
times
expansion
that
of the
Earth.
universe,
While
will
we
become
don't
the
yet know
dominant
whether
force,
Kepler
and all remaining
452b
cosmic
has
structures
an
will
atmosphere
drift
or the
apart.
conditions
The
necessary
universe,
for life,
which was once
the
teeming
fact
with
that it is
stars
so
and
similar
galaxies,
to Earth
will be
makes
left
it a
as an
prime
empty
candidate
void,
for further
with only
study.
isolated remnants
The
of its
discovery
former
of
grandeur.
Kepler
Throughout this
452b
process,
is
however,
one of the most
Quipu
exciting in the
and other
search
large
for
structures will
extraterrestrial
still serve
life,
as important
as it
symbols.
suggests that
Even in
Earth-like
their final
planets
moments,
may
they are
be
the
more
last
common
echoes
in the
of the
universe than
universe's
previously
dynamic
thought.
past. However,
As the
even
universe
as we
continues
search
to
for planets that
expand,
could
these
potentially
structures
support
will
life,
stand as
we
monuments
must
to the
also
incredible
confront the
forces
reality
that
that
shape
not
the
all
cosmos.
planets are
They
hospitable,
will be reminders of
and
the
many
vast
of them are
scale
so
of the
extreme
universe
and
and
the
the remarkable
everything
forces
we
that
know
brought
about
it
the
into
universe.
existence. The
These
discovery of
large-scale
planets like
structures,
HR5,
which are composed of galaxies and dark
a gas
matter,
giant,
are not
with an
just
incredibly
scientific
eccentric orbit,
curiosities,
shows
they are
just how
reflections of
strange
the
and
very nature
unpredictable
of the
planetary
universe.
systems can be.
They were formed through the forces of gravity and dark
HR55183b
matter,
orbits
and
its
their
star
eventual
in a long,
disintegration
looping
marks the
path,
end of a cosmic
taking
cycle
between
that began
45
shortly
and
after the
100
Big
years
Bang.
to complete.
While we may
One
never see
full
the end
orbit.
of these structures,
The planet's
their
orbit
journey
is
is
so
a testament
elongated
to the
that at certain
impermanence of all
points it
things
swings
in the
closer to
universe.
its star
As
than
the
Jupiter
universe
is to the
continues to
Sun,
expand,
only to
the
swing
connections
back out
between
to
structures like
distances
Quipu
beyond
will become
Neptune.
increasingly
This bizarre
distant.
orbit
These
has
once
earned
massive systems,
HR518-3b
which stretched across
the nickname
billions
the
of light
Whiplash
years,
planet,
will
and
eventually
its
become
discovery
isolated,
challenges our understanding
disconnected
of how
islands in a
planets
cold
form
and
expanding
evolve.
void.
The most
The
fascinating part of
gravitational pull that once held
HR518-3b's
galaxies
orbit
together
is
will
that it
weaken,
suggests the
and the
planet
galaxies
was once
within
part
those
of a
clusters
binary
will
star
drift
system.
farther apart.
At some
Over
point,
time, even the largest
HR518-3b
and
was
most
ejected
powerful
from its
structures
original
in the
orbit
universe
and sent
will
on a
fade
highly
into
elliptical
isolation.
path around
In
its
the
new
end,
star.
the universe
This
will have
unusual
completed a
orbital
full
path
circle.
has raised
The
questions
Big Bang,
about the
which
formation
gave
of
rise
planets
to
in
everything,
binary star
will have
systems,
stretched into a
and whether they
vast
can
and
eventually be
incomprehensible
expelled
from their original orbits.
The structures we
leading
see
to
today,
strange and unpredictable
galaxies,
orbits,
clusters,
like the one observed in
superclusters, will be gone,
HR518-3b.
having reached their
These
limits.
bizarre worlds,
The end of the
KELT,
universe will not come with a sudden
9b,
cataclysm, but with the gradual
TRAP,
fading of everything we know
PIST,
into emptiness.
1D,
Yet, in a way,
Kepler,
this will be the ultimate achievement.
452b,
The universe, though vast and
HR518-3b,
isolated,
are just
will
a
have come
few of the
full
countless
circle,
exoplanets
creating
that
itself
exist
through
in
its
the
own
universe.
expansion.
Some of
Creating
these
planets
structures we now
challenge our
observe,
understanding of the
only
basic
to eventually
laws of
lose
nature,
them,
while
even as
others
the final
provide us
stars
with
flicker
valuable
out
insights
and the galaxies
into the
drift
processes
apart.
that govern
The
planet
universe will have
formation
left
and
behind a
evolution.
legacy of
But
cosmic
no matter
history,
how extreme
a
or
memory of the
unusual
forces
these
that
worlds may
shaped it.
be,
We,
they all
as
share
part
one
of this
thing in
universe,
common.
are not
They
immune
remind
to
us
the
just
passage
how
of
little
time.
we truly know
As we
about
contemplate
the
the
universe.
end of the
Each
universe,
new discovery
we must
opens up
recognize
new
our own
questions
place
and reveals
in
new
this
mysteries.
vast,
And the more we
unfolding
learn,
story.
the more we
Our
realize
lives,
how vast
brief as
and
they may
strange
seem,
the cosmos
are intimately
truly is.
connected to
The
the
deeper we
universe's
venture into the
evolution.
cosmos, the
The
very
more we
atoms that
realize
make up
that
our
the
bodies
universe,
were once
with all
forged
its
in the hearts
majesty
of
and
ancient
enormity,
stars,
is not merely a
and in
vast
turn,
collection
they will
of stars
cycle
and
through the
planets.
universe.
It is a
contributing
paradox.
to the ongoing
It is a
cosmic
place of
story
beauty and
long
terror,
after we are gone.
harmony and chaos,
As we peer into the
serenity
farthest
and
reaches of the
violence.
universe's
The more we
timeline,
learn, the more
we
we
begin to
understand
realize
that
that
the cosmos
Quipu
is
and
a
the
realm of
cosmic
extremes,
represent not
a
just the
universe
current
that
state of the
defies our
universe,
understanding
but the
and
culmination
challenges
of
the
billions
limits
of
of years
imagination.
of cosmic history.
Each discovery
The
pushes
creation,
us further into a
evolution,
space
and
where the
eventual
familiar rules
breakdown
no
of these
longer
large-scale
apply,
structures
and we are
are a
forced to
testament to
confront
the
the
immense
unknown.
forces that have shaped
Consider the
cosmos.
planet
But these
WASP,
forces are not just about cosmic
76b,
matter, a gas
They
giant
also
located around
illuminate the
640
fragility of the
light-years from
universe
Earth.
itself.
The
Orbiting a star
inevitability
much
of
hotter
cosmic
and more
isolation
massive than
and
our
entropy
Sun,
means that,
discovered in
despite the vastness of
2016,
what
we see today,
WASP
the universe is heading toward a
76b
point of
presents a
cosmic
world
decay.
that seems more like
The
a
end is
nightmare
not
than a
sudden
planet,
or violent,
a world
as
where
we
the
once
laws
might
of
have
nature are
imagined,
distorted
but
by
rather
the ferocity
slow
of the
and
star it
gradual.
orbits.
The unraveling
This
of cosmic
exoplanet
structures
is a
like
perfect
Quipu
example
signals
of how
the end of an
extreme
era,
and inhospitable
a shift
the
from
universe
cosmic
can be.
activity to
Its
cosmic
surface
stillness
temperature
reaches up to
this quiet,
2,400
gradual
disintegration
degrees
of the
Celsius,
cosmic web will have profound implications for our
Fahrenheit,
understanding of
a heat
existence
so
and
intense
time
that
itself.
it could
The
melt
idea that
rocks and
everything
metals.
is in a constant
The
state
planet's
of
day
flux,
side is scorched by
constantly
its
moving
star,
toward
while
greater
the night
complexity
side
and
is
order,
freezing cold.
will slowly give way to the
temperature
reality
difference between
that
the
all
two
things
sides
are
is so
ultimately
extreme
bound
that
to
it
decay.
generates winds of
The
unimaginable
universe
strength,
itself no matter
winds
how
that carry
vast or
molten
powerful
iron
it may
across the
seem,
planet,
is a
creating
temporary
iron
system.
rain. And eventually,
Scientists have
every
even
galaxy,
speculated that the
every
atmosphere
star,
of
and every structure
WASP
will be reduced to
76b
nothingness.
may contain
We
clouds
must,
made of
however,
iron,
ask
and that these
ourselves,
clouds
what does
condense
this
and
mean for
precipitate
us?
as molten iron
What does
rain
it
during
mean
the
that
night.
despite all
The
our
temperatures on the
accomplishments,
day side are so
discoveries,
high
and
that
innovations
the gases on the planet's
the
surface
universe,
are constantly
our
in a state
home,
of flux,
will one day be
moving
isolated
from one
and
extreme
empty.
to another.
The answer
As
is
if the
not
planet
just about the
itself
fate of
is
the
constantly
stars or
trying
the
to
ultimate
balance the
isolation
forces
of
of
large
destruction
structures
and
like
creation.
Quipu, but
That
about
is not all.
perspective.
That
From
makes
our vantage
WASP
point on Earth,
the universe seems
76b,
vast,
extraordinary.
permanent, and
In
unchanging.
2021,
Yet when
researchers
we zoom
confirmed
out
the
and take
existence
into
of a
account
glory
the cosmic
on the planet,
timeline,
an
the
atmospheric
reality
phenomenon
becomes
never
clearer.
before seen
The
outside of our
universe,
solar system.
like all things,
A glory is a rare
temporary.
optical effect
The only
caused by
constant
the
is
reflection
the
of
unfolding
sunlight off
passage
water
of time,
droplets or clouds
and the
in the
forces of
atmosphere.
gravity
The
and
fact
dark
that a
energy
glory
will
was
eventually
detected
wear
on a
down
planet
everything
like
we know.
WASP,
The legacy of the
76b,
cosmic web,
which is so
an
incredibly
enduring
hostile to
understanding,
life,
even as
is
Quipu
both a
fades into
remarkable
cosmic
and
oblivion.
sobering reminder
The
of how
knowledge we gain
strange
from
and
studying
unpredictable the
structures
universe
like it
can be
will endure.
What is truly
The
astonishing
legacy of the
is
cosmic
that
web and
WASP
galaxy clusters will not just be the
76b
facts we gather,
is just one
but the
example
understanding
of
they
many
provide about the
exoplanets
nature
that
of
challenge
existence.
our understanding of the
Quipu's structure,
universe. The existence
composed
of
of dark
such
matter,
extreme planets
hot gas,
raises
and
important
gravity
questions
will
about
forever
the
mark
nature
the pinnacle of
planetary
our comprehension
formation
about how
and
the
potential
universe
for life
forms
beyond
and
Earth.
evolves.
Can
In the
life
distant
exist on a
future,
world
when
where
the
lost
molten
galaxies
iron
have
rains
drifted
down
into
from the
isolation?
sky?
Could organisms
We will
still
survive
carry
on a
the
planet
memory of this
where
grand
temperatures
design,
swing from
the
blazing
laws of
heat
physics
to freezing
the
cold
forces
in a
of
matter
nature,
of hours?
and the
The
cosmic
more we
principles
discover,
that have
the
shaped
more we
the
realize
universe
that our
will
understanding
continue to
of life
exist,
and its potential
even as the
is
universe
far more
fades
limited
into
than we
nothingness.
once believed.
The
But
knowledge
while
we've
planets
gained
like
from studying
WASP
these vast structures
76b
will
push
persist,
the boundaries of what
echoing
we
through
thought
the
was
far
possible.
future.
They
Even in
also
the absence
serve
of
as a
stars,
reminder that the
galaxies, and
universe is
clusters,
far more
the
diverse
universe will
than
carry
we could ever imagine.
It will be
Not
a
all
quieter,
exoplanets
emptier
are
place,
inhospitable or hostile
but it
to
will
life.
still carry the
Some are
imprint of
remarkably
everything that
similar
has
to
happened.
Earth,
The
existing
forces
in
of
the
gravity,
habitable zone,
dark matter,
the region
and
around a
dark
star
energy
where
will
conditions are
continue to
just
shape
right
this
for
liquid
liquid
water
water
to
to
exist.
exist.
One
albeit
such
in
planet
more subtle
is
ways.
Kepler. We may never witness the
452b,
final dissolution
often
of
referred
Quipu
to
or
as
the
Earth
cosmic web,
2.0,
but the understanding we have
located
gained
about
from our study of these
1,400
structures
light-years
will
away.
resonate throughout
Kepler,
human history.
452b
The future of cosmic
is a super
discoveries
that
while we are
orbits
still
a star
living in the
similar
active
to our
phase
own
of
sun.
cosmic evolution.
It is the first
It is
planet
important to
discovered
remember
that
that
shares
the
many
end
of the
cosmic
characteristics
structures
of
like
Earth,
Quipu,
including
does
its
not signal
size,
the end of
temperature,
cosmic discovery
and orbit.
Instead,
Kepler,
it is a reminder that we are part of a
452b
much
lies
larger,
in its
ongoing
star's
journey.
habitable zone,
The future
where
of
temperatures
cosmic
are just right
exploration
for
lies
liquid
in the
water
hands
to
of the
exist
next
on its
generations
surface.
of scientists.
The planet's size,
astronomers,
roughly
and
1.5
physicists.
times that
The
of
tools
Earth,
we use to
makes it
explore
a
the
prime
cosmos will
candidate
continue to
for studying
improve,
the potential
allowing
for
us to
life
see
beyond
farther
our solar
and in
system.
more detail than ever before.
452b
New
has an
telescopes
atmosphere
like the
and
James
right
Webb
chemical
Space
conditions
Telescope
and
could very well
gravitational
harbor
wave
life,
observatories will
but
unlock
the
new
discovery of
dimensions of
Kepler
the cosmic web,
revealing secrets that were once
452b
beyond our reach
is not just about
These
the
tools will
potential
allow
for
us to
life.
explore parts
It
of
is
the
also
universe
about the
that were
possibility
previously
of
invisible,
finding a new home
such
for
as dark
humanity.
matter and dark
As we
energy.
continue to
The
explore
discoveries
the
of the
universe,
future will continue
planets
to
like
push
Kepler,
the boundaries of our understanding.
452b offer a
Even
glimpse
though we
into
are
what
aware of the
future
ultimate
space
fate of the
exploration
universe,
could look like.
there is still so
Could we
much
one
more
day
to learn.
colonize a
From the
planet
discovery
like
of
this,
new galaxies
ensuring
into
the survival of the
planetary
human
systems,
race for
to
millions of
understanding
years
the
to
mysteries
come?
of dark
While we are
matter
still a
and
long
dark
way
energy,
from such a possibility,
there will always be
the
new
discovery of
horizons to
Kepler,
explore.
452b,
As technology
has opened the door
advances
to
and
new
our understanding of the universe
and
deepens,
has given scientists
we may
hope
one
that
day
Earth-like
uncover the
planets
nature
are
of
more
dark
common than
energy,
we once thought.
the origins of
However,
life,
not
and the
all
fate of the
discoveries in the
universe
search
with
for
even greater
habitable planets
clarity
have been so
The universe
optimistic.
is vast,
As we continue to
mysterious,
study
and
the
full of
universe,
wonders,
we are
and even as
constantly
it moves
confronted by
towards its
worlds that
eventual
are
end,
utterly alien.
our
and often
curiosity will
downright
drive us to
terrifying.
continue exploring and understanding. A quiet future,
1D, for example,
the long
is a
cosmic
rocky
planet
planet in the
that
far
orbits a
future,
small dim star
long
about
after the
40
last
light
stars
years
have burned
away.
out
While
and
it
the
lies in the
galaxies have
habitable
drifted
zone
into
of its
isolation.
star,
The
scientists have
universe will be a
discovered
very
that its
different
surface is
place.
subjected
The
to
structures we know and
tidal
love,
heating,
like
which
Quipu,
results in
will no
massive
longer be
tectonic
recognizable.
activity and
The
violent
cosmic web,
volcanic
with
eruptions.
its filaments and
The planet
clusters,
is
will have
constantly
faded
being
into the
reshaped
distance,
by the forces
leaving
of nature,
behind a dark,
and its surface
cold
is
void.
far from the peaceful,
The universe will
life-supporting
be
environment
dominated by
we
black
might
holes,
expect from a
white
planet
dwarfs,
in the
and
habitable
neutron
zone.
stars,
Even though
remnants of the once
TAAP,
thriving cosmos.
the relentless expansion will continue.
1D is in the
But
right
there will be
location
little
for
to
life
see
to
or
exist.
observe.
Its
The
extreme
universe will grow
conditions make it
colder,
highly
and the light
unlikely
from
that it could
distant
support
stars will
life
no
as we
longer
know
reach
it.
us. In fact,
Even as we look
the
toward
universe
the
is
end of the
filled
universe,
with planets
there
like
is something beautiful about it.
PIST.
The universe has
1D
always
worlds
been in a
that
state
seem to
of
have the
constant
right conditions
change,
for life,
and though it will
but are
eventually
ultimately
fade,
inhospitable
it will
due
do
to
so with
extreme
dignity.
geological or
The forces that have
atmospheric
shaped
conditions.
it, gravity,
One such world
dark
is
matter,
HD
dark energy,
189,
will continue their work
733b,
until the very last
a
remnants
gas
of the
giant
cosmos are
located
gone.
about
The final
63
chapters of
light-years
the
away.
universe's story will be
HD
quiet,
189,
filled with nothing but the faint echoes of what once
733b
was.
is a
In the
planet
distant
so
future,
extreme
as
that its
Quipu
winds
and
blow
other
at speeds of
large-scale
up to
structures
8,000
continue to
kilometers
fade
per
into
hour,
cosmic
5,000
isolation,
miles per hour,
the universe
and its
will
surface
undergo
is
a
constantly
profound
bombarded by
transformation.
intense
The
radiation
physical
from its
forces that
star.
once
The
shaped
planet's
galaxies,
atmosphere is
clusters,
thick with
and
silicate
superclouds,
clouds, and the
will lose
temperature
their
on its
influence
base
as
as
dark
dark
energy
energy to
continues
1,000
to
degrees
stretch space.
Celsius.
The forces of gravity that once held the
1,832
universe's
degrees
large
Fahrenheit.
structures
To make
together
matters
will
worse,
weaken,
the
and
planet's
the very
atmosphere
fabric
is
of the
constantly
cosmos will
being
become
stripped away
stretched
by the
and
heat
thin.
of its star.
This will be the
with the
universe's
planet losing
final
mass
phase
at a rate of up to
a
3
period of
million
stillness,
tons per second.
marked by
But
the
perhaps
slow
the most
disintegration
disturbing
of
feature
everything
of
that
HD
once formed the
189
vibrant dynamic universe
is the fact
we
that its
observe
winds
today.
are so
Once the
powerful
last stars
that they
burn
could
out
literally
and the
cut
black
through the
holes finally
atmosphere like
evaporate,
knives.
the
intense
universe will
heat
become
and
a much
high-speed
quieter
winds
place.
make the planet an
There will
utterly
be no more
inhospitable
light from
place
distant
for life,
stars to
and
illuminate
it is
the
difficult
vastness
to
of
imagine
space.
any form
No
of
more
life
galaxies to
surviving
make
in
sense
such
of
an
the
environment.
cosmic landscape.
Instead, all
Yet,
that will
despite
remain
its
will
extreme
be
conditions,
darkness. A
HD
profound
189,
empty void in which the
733b
concept of time
remains
and
one of the most
distance
studied
will become
exoplanets.
irrelevant.
As scientists
The great
continue to
cosmic
learn
drama
from
that
its
we are
violent
part of
atmosphere
will
and
come to a
extreme
close,
weather patterns,
not with a bang.
the
but
more
with a
we learn
slow,
about
quiet
planets like
fading
HD
away.
189,
However, the
even
more
as
we
cosmic
realize that
structures
the
like
universe
Quipu
is
fade
full of
into
worlds that
nothingness,
are beyond our
their legacy will
comprehension,
live on.
worlds where the
The
laws of
information
nature
and
are
discoveries that
stretched
we
to
have
their
gathered
breaking
over the
point.
millennia
In
will
our search
continue
for
to shape how we
exoplanets,
understand
we are
the
constantly
universe,
reminded
long
that the
after the
universe
cosmos
is a
has
realm of
reached its final
extremes.
stage.
The
Some
lessons we've
planets are
learned from
incredibly
observing
hot,
Quipu and
others
other
are
massive
freezing
cosmic
cold.
structures
Some are
will be
violently
passed down
stormy,
through
while
generations,
others are eerily
leaving
calm.
behind a story.
Some planets may harbor
a
life,
story of how the
while
universe
others are completely
evolved,
lifeless.
expanded,
But no matter
and
what we
eventually
discover,
succumbed
the
to
fact
its
remains
fate.
that we are just
And
beginning
while we
to
may not
scratch
be
the
around to
surface
witness
of what
the
is
final
out there.
moments of the
The universe is
the
vast
knowledge and
and
insights we
mysterious,
gained from
and
our
with every
study
new
of the
discovery,
cosmos
we are
will live
reminded
on
of
in the
how
records
little we
leave
truly know.
behind.
As
The
we journey
cosmic
further
web is
into
a
the
reminder
cosmos,
of our
we
place
begin
in the
to move
universe,
beyond the known,
the cosmic
into
web,
the territories of the most mind-boggling
mind-boggling
celestial bodies
and
that
filaments
science continues
represents
to
the
uncover.
grand scale of the
If
universe.
you thought exoplanets
But it
couldn't
also
get
serves
stranger,
as a reminder
think
of our
again.
humble
Our
and
universe
temporary
is so
existence
unpredictable
in this vast
that
expanse.
new discoveries seem
As
to
we
rewrite
contemplate
the very
eventual
rules
isolation
we
of
once
structures
held
like Quipu,
Consider for a
we are
moment
confronted with
the
the realization
inhospitable
that
molten
everything we
surface
know
of
our
WASP,
galaxy, our planet,
76b,
and our lives
a gas
is
giant
part of a much
situated
larger story
640
that
light
extends
years
far
away from
beyond our
Earth.
understanding.
This
In the
planet
grand scheme
isn't
of
just a
things,
hot
the human
spot,
experience
it's
is
a
brief.
boiling cauldron,
We live for mere
a world
decades,
that seems to
a blip
exist
in the
only
cosmic
in the realm of
timeline,
nightmares.
and yet our ability to contemplate the
WASP,
universe, to study its structure,
76b's
its
proximity
evolution,
to its host
and
star
its future
has caused its
gives us a
surface
unique
temperature to
position.
soar to
We are one of the
unimaginable
few
heights,
species that can
reaching
look
outward
outward
to
and grasp the
2,400
immensity
degrees
of the
Celsius.
cosmos.
As we move forward into the
4,400 degrees
future,
Fahrenheit.
it's easy
Imagine
to
a
become
world where
preoccupied
iron
with our
doesn't
day-to-day
just
struggles,
exist as a solid,
our careers,
but rains
our
down in
relationships,
molten
our
form,
problems. But the
flowing
study of the
freely
universe
like liquid
forces
metal.
us to step
A
back
bizarre
and see how
storm of
small our
molten
personal
iron
concerns
pouring from
are
the sky.
in the grand context of
Scientists
cosmic time
studying
and scale.
WASP
Quipu and other cosmic
76b
structures
have
have lasting
speculated
testaments
that the
to the
planet's
power of the
extreme
universe,
and
our
our
close
close
orbit
orbit
to
to
its
its
star
star
fleeting
may
moment.
cause its day
This
and night
awareness
sides
provides
to
us with a
experience
humble
radically
perspective.
different temperatures.
When we look
during
at the night
the day,
sky,
the
we
side
see
of the
stars
planet
and
facing
galaxies
its
that are
star
not just
burns
lights
with
in the
such
sky,
intensity that
but
the air is
symbols of the
filled with
vastness and
evaporating
complexity
rocks,
of existence.
which then condense as
The
the
cosmic
planet
web
rotates,
reminds us that we are
creating
part of
clouds of
something
molten
far
iron.
bigger than
Yet
ourselves,
it doesn't stop
something
there.
that stretches across billions of light
WASP
years,
connects galaxies,
galaxies, gravity
and extends
causes
far
this
beyond
molten
our
iron to
perception.
accumulate on its
This
dark
perspective
side,
can help
and
us
it's these very
reevaluate our
clouds,
priorities.
these iron-filled
Instead of becoming
storms
bogged
that
down
might
by the
precipitate down
trivialities
as
of
molten
daily life,
droplets during the
we
night.
might consider
It's a
the
larger
wild,
picture,
chaotic cycle
the
of
universe
day and
we're
night
part of
that offers
and
a
the
glimpse
future
into a
it
universe
holds.
far
The
stranger
knowledge and
than
curiosity
anything
we
we've seen
continue
here
to
on
cultivate
Earth.
about the cosmos
For a planet
will
this
remain
close
with
to
us,
its star,
serving
the
as
sky
a guide
isn't the
and
only thing that's
inspiration,
scorched.
no matter
Even
how
the
the
very
universe
air
changes.
filled with iron
The
particles
lasting mystery of
carries
the
the weight
of this destruction.
What lies beyond.
However, the story of
contemplate the end of the
universe,
it's
76b,
impossible to
doesn't
ignore the
end
vast
with
unknowns
molten
that
iron
still
rains
remain.
and scorching
The
heat.
universe is full
This
of
planet
mysteries,
is part of a
from the
growing
nature
list
of dark matter and
exoplanets
dark energy
that are
to the
eerily
true
alien in
origins of the
nature.
cosmos itself.
Worlds that defy logic.
Though we've come far in our
breaking the norms
understanding,
of planetary
there is still so
formation.
much about the
While
universe
some
that remains
exoplanets are
hidden
larger
from us.
or smaller
One of the
than
most
anything
profound
seen
questions
before,
is what lies beyond the
76b
observable
remains
universe.
a symbol of how
While we
distant
can see a
planets,
small fraction
once
of the
thought to be
universe,
impossible,
about
are becoming
46.5
startlingly
billion
real.
light-years in orbit. directions.
It's not just the extreme
The
conditions
reality
on
is that there is likely
WASP
much more out there that we
76b
cannot
that
see.
fascinate us.
As the universe
But the fact that
continues to
science
expand,
is now beginning to
regions
collect
of
data
space will
on these
move
worlds,
beyond our cosmic
worlds
horizon,
that are hundreds,
out
if
of
not
reach of any
thousands
future
of light years
explorers
away.
or telescopes.
Consider this:
If the universe
when
is infinite,
scientists
as
first
some
began
models
detecting
suggest,
exoplanets,
then beyond our
they used
observable
methods
realm,
like the
there could
transit
be more
method,
galaxies,
where a planet blocks out a
clusters,
portion
and
of its
structures
star's
that we
light
can't even
as it
begin
moves
to
across
fathom.
the sky.
We are left to
Over the
wonder
years,
what
they've
lies
developed
beyond.
ever more
Could there be more
sophisticated
cosmic
ways
webs
of observing
like
these
Quipu,
worlds, larger
using
structures,
instruments
or
like the
entirely
Kepler
different
Space
types of
Telescope
cosmic
and
phenomena
the transiting
that exist beyond the
exoplanet
edge of
survey
our
satellite?
observation.
But as these
And if the
telescopes reveal
universe is
more
not
about
infinite
distant
but
exoplanets,
finite and
it becomes
unbounded,
clear that we're only
could there be
beginning
a
to scratch
boundary
the
to
surface.
everything,
A
and
limit
yet
to the
there is
entire
something
cosmos
haunting
that we
about
cannot
the thought
cross.
of how little
This
we
question
truly
remains one of
understand
the
about
greatest
these
mysteries
planets
in
and their
cosmology.
environments.
And even though
The
we
next
may never
mystery
find
comes
the
in the
answer,
form of planets
it's
that
part of
don't
what drives our
justify
curiosity about the
expectation.
universe.
They create new
We continue to
categories
search,
search,
to observe.
Take, for
and to
example, the
question,
planet 55
because the
Cancri,
possibilities are endless.
a world
The
made of
human
almost
quest for
entirely
understanding.
diamond.
Yes, you
The
heard that
legacy of
right.
discovery,
A planet
despite the
that could
cosmic
potentially be more
uncertainty,
precious
there is something
than all the
undeniably
diamonds
human
on
about
Earth
our quest
combined.
for knowledge.
Located
The
about
search for
40
meaning
light
and
years away in the
understanding in the
constellation
vastness of the
Cancer,
universe
55
is not just a
Cancri
scientific
is an
pursuit,
exoplanet
but a
that
deeply
has
personal
intrigued
one.
scientists
We
ever
seek
since
to
its
understand
discovery,
where we come
with
from,
a mass
what we
7.8
are,
times
and
that
what
of
our
Earth,
places in
and
the
a
universe.
composition primarily
This
of carbon.
quest for answers
Scientists
is woven into the
speculate
very
that the
fabric
planet's
of our
close orbit
existence.
to its star
Through the
has
discovery
caused the
of
carbon to
structures like
crystallize
Quipu
into
and
diamonds.
our continued
This
study of the
extraordinary
cosmic web,
discovery
we have learned
challenges
that the
our
universe is
preconceived
far more
notions about what
intricate
planets
and vast
can be
than we
made
could
of.
have ever imagined.
For many, the
And
idea
yet,
of a
as we
planet made
explore,
entirely of
we
diamonds
realize that we are
sounds
only
like a science
scratching the
fiction
surface.
dream.
There is much more
But
to
it's becoming
discover,
clear that
and
the
each
universe
new
is
piece of
capable
knowledge
of
brings us
creating
closer
worlds
to
far
understanding the
stranger
grand
than we
design
could
of
ever
everything.
imagine.
Even
On
though the
55
universe will
Cancri,
eventually
the heat and
fade,
pressure near its
our
star
ability
are so
to
intense
comprehend
that
its
the
wonders
carbon on the planet
is
has
something
undergone a
that will remain
transformation.
with us.
In
this
turning
sense,
it into
the
solid
universe
diamond.
will live on not
What's
just
even
in its
more
final
surprising,
moments,
however,
but
is
in
that
the
this
legacy
planet
of
may
the
not be
knowledge
as
we have
alien in
gained.
nature as we once
The discoveries
thought.
we make
Despite
today,
its extreme
the
conditions,
questions we ask,
scientists
and the
have found
answers
that
we
planets
find
like
will
55
continue to
Cancri
shape our
can
future,
provide valuable
long after the
insights
stars
into
have
the
gone
formation
out
of planets
and the
in
last
our
galaxies
own
have become
system.
isolated.
Their existence
Conclusion:
serves as a reminder
embracing
that
the
planets
infinite
aren't bound
wonder.
by a single set
In
of
the end,
rules.
while we
Each
can
new
predict the
discovery
unraveling of
adds
cosmic
to the larger
structures like
picture
Quipu
of how our
and the
universe
ultimate
works.
isolation of the
Even
universe,
if it doesn't align
we
with
can also
anything
take
we've
comfort
seen
in the
before.
knowledge that we
This
have been
brings us to
part
an
of
equally
something
fascinating
extraordinary.
discovery.
The
potential for
universe,
life on
in all
planets
its
we never
vastness,
thought would
has
support it.
provided us with an
In
endless source of
2015,
wonder,
astronomers discovered
curiosity,
Kepler
and
452b.
discovery.
As
A
long as
planet
we
that has
continue to
earned the
ask
nickname
questions
Earth's
and seek
cousin,
knowledge,
located
we will remain
1400
part of that
light years
ongoing
away from
cosmic
Earth.
journey.
Kepler,
When we look up at the stars,
452b,
we are not just
lies
seeing
in the
points of
habitable
light.
zone of its
We
star,
are looking at the
much
history
like
of
Earth
the
does with
universe,
the sun.
a history that
region,
stretches back
often
billions
referred
of
to as the
years and
Goldilocks
will continue
zone,
to evolve
is the
long
sweet
after we
spot
are
where
gone.
conditions are
And
just
while
right
the future
for
of the
liquid water
universe
to
may be
exist
one
on a
of
planet
darkness and
surface.
isolation,
This
the
discovery
legacy
sparked
of
excitement
excitement
among
among
the
the
scientific
scientific
community
will be a reminder
as it's
that
one of
we
the
have
most
understood,
Earth-like
at least in
exoplanets
part, ever found.
the vast
However,
cosmic web that
even as we
connects us all.
marvel at the
As we
possibility
stand
of life
here,
on planets
in the
like
midst
Kepler,
of all this cosmic wonder,
452b,
it's important to remember that our time in the universe is not as straightforward as we'd like it in
to
the
be.
grand tapestry of
Kepler,
existence.
452b
Our lives
star,
are a
although
mere
similar
blink.
in nature to our
And
sun,
yet,
is
for all
about
our
1.5
we
billion
possess
years
something
older,
extraordinary.
meaning that the planet
The
might be
ability to
subject to much
comprehend
more
and
intense
connect with the
radiation and
universe
heat
on a scale
than
that
Earth
is
never
nearly
experienced.
incomprehensible.
This
Looking
raises
at the farthest
questions about
reaches
the
of
long-term
space,
habitability of
structures
Kepler,
like Quipu,
452b,
the largest coherent
and how
structure
other
ever
factors,
discovered, we can
such as
feel
its
small
atmosphere
and insignificant.
and the nature of its surface.
After all, a structure
might
spanning
impact its
1.4
ability to
billion
support
light years
life.
is almost too
In the
large
grand
to
scheme
even
of
fathom.
things,
Yet,
Kepler,
it's the very fact that we can
452b,
comprehend such a
serves
vast
as a
thing
reminder
that makes
that
us
even
so
though we are
unique.
still far from
We are not
understanding
only
the
living
vast
in this
complexity of the
universe,
universe,
we are
there
in
are
a way
worlds out
becoming
there
one
that
with it.
resemble our own.
Understanding
And though we
its
might never set
deepest vast
foot on
workings
these distant
and contemplating
exoplanets,
its greatest
each new
mysteries.
discovery
The
is a
universe's
piece
end,
of the
when it
cosmic
arrives,
puzzle that
will be
continues
quiet
to
and
evolve.
slow.
Every star,
Quipu will
every
eventually
planet,
fade into
every
isolation,
moon that we uncover,
as will every other
brings us
galaxy
closer
to understanding the universe's true
today.
nature. The last
And
stars will burn
to
out,
answering the
leaving
age-old
only black
question,
holes and dark
are we
remnants
alone
of what
in the
once was a
universe?
thriving
Yet
cosmos.
even as we search for
The
the
universe
familiar,
will become an
we
empty,
encounter
cold
the
void,
utterly alien,
stretching endlessly,
planets that bear
devoid of
little
light,
to no resemblance
motion,
to
or
Earth
change.
at all. There will
Consider
be no more
HD
galaxies
189,
being formed,
note
no more
733b,
stars being born.
a planet so
The
hostile
universe will
that its
have run
rings
out
are
of
made of
steam,
molten glass,
its potential
capable of
exhausted
cutting
by
through
the
anything that
inexorable
gets
forces
caught in
of
its
dark
torrential
energy and entropy.
downpours.
Yet,
This exoplanet,
even as the universe
located
winds
63
down,
light-years away
something
from
remarkable
Earth,
remains.
has temperatures that soar to
Humanity,
more than
in its
1,000
short time on
degrees
this planet,
Celsius,
has uncovered the
1832
wonders of
degrees
the
Fahrenheit,
cosmos,
We've
making it
discovered the
impossible
cosmic
for
web.
any life
We've
as we know
mapped
it
out
to
the
exist
largest
there.
structures in
The
the
planet's
universe,
atmosphere
and
is
we've
filled
gazed
with
upon the
scorching
heavens,
winds that
striving
carry
to
shards of
understand
glass,
them. Our
moving at
journey may be
speeds of
brief in the
4,000
grand scheme
miles
of
per
time,
hour.
but our
These
curiosity
winds,
is
combined with
timeless.
the
As we
planet's
look at the
intense
night
heat,
sky,
create
we are
a
looking
hellish
back in
environment
time,
that is as
seeing
alien
stars
as it
and
gets.
galaxies as they were
HD
millions,
189,
billions of years ago.
733b
And yet,
is
in
what
that
scientists
very act
call
of
a hot
observing,
Jupiter,
we are part of
a
a
gas
grand
giant
continuum.
that orbits its
Every
star
star
at an
that lights up the
incredibly
night,
close distance,
every galaxy
resulting
that
in
swirls
scorching
in the
temperatures
darkness
and extreme
is a
weather
piece of the
patterns.
story of
And
the
just like
universe.
that, we
And we are
encounter another
actively
example
contributing
of
to
how
that
the
story.
universe can
Our
present us with
capacity to
worlds
ask questions
that are both
to
awe-inspiring
sequences and
and
to connect
terrifying
the
in their
dots
extremes
is a reflection of our place in this
For
vast,
scientists,
mysterious
the study of
cosmos.
these
As the
extreme
universe
exoplanets
enters its final
offers us a
stages,
glimpse into what
we
might
can
be
only
happening
imagine
on
what
other
the
planets
last moments will
in
look
distant
like.
corners of the universe.
But perhaps there is beauty
Worlds
in the
that defy
quiet
our
end,
very
the
understanding
stillness
of
of a
what makes
universe
planet
that has lived its
habitable.
life.
But
And
perhaps
in
the
the
most
knowledge that we
terrifying
were
part
once
of these
part of it,
discoveries is the
informed,
realization that
aware,
for every
and
Kepler
curious about its
452b,
the end
or
does not
Earth-like
diminish the
exoplanet,
importance
there
of
are
the
countless
journey.
other planets
It
where
only
the
adds to the
conditions for life
mystery
as we
and the
know it do
majesty
not
of the
exist.
cosmos.
When all is
Some
said and
planets
done,
may have
the most
atmospheres
profound
too
aspect
thick,
of this
while
journey
others
through
may
the
be
universe is
bombarded
that
by
we too
radiation
are
or
made of the
scorching
same
heat.
stuff. Still,
The atoms
these
that make
extreme
up our
worlds
bodies
serve
were
as a
forged
reminder
into
of the
ancient
incredible
stars,
diversity
that
that
lived and
exists
died
across
long
the
before our
universe.
planet
And
ever
as
came
we
to
push
be.
the boundaries
We
of
are,
our
in a very
understanding,
real sense, part
one
of the
discovery at a
universe,
time,
shaped
we can
by
only
the
imagine
forces
what
that
other
shaped
strange and
everything
wondrous
else.
worlds await
Our
gaze.
ability to
As we
contemplate,
continue
to
to explore the
understand,
depths of
and
the
to
universe,
connect with the cosmos
we encounter not
is a
only
testament
planets
to the
and
wonders
stars
of
that stretch
existence
the limits
itself.
of our
And
imagination.
as we look up at the stars
but
tonight,
also celestial
we know
phenomena
profound
that exist beyond
we
the
are not
comprehension
merely
of
observers
most.
of the universe.
Just when we think
we
we have
are,
uncovered the
in a
most
sense,
bizarre worlds in
the
existence,
universe observing
new
itself.
discoveries
Every
reveal
question
even
we
more
ask,
strange and
every
frightening
discovery we
realities.
make,
Is a
the
reflection
universe,
of our
it
deep
seems, has
connection
no
to the
boundaries for
cosmos,
what is possible
a
or
connection
impossible.
that, despite
One
such
such
vast
phenomenon,
distances and
perhaps,
unimaginable
one of the most
timescales,
baffling,
will never
is the
fade.
discovery of rogue planets.
So, as we reach
these
the
are
end
worlds
of this
that
cosmic
wander the
journey,
vastness of space
remember,
without the tether
we
of
are
a
part
star,
of something
isolated
far bigger
and
than
lost in the
ourselves.
cosmic abyss.
Our lives may be
For these
brief,
planets,
but the story of the universe will
defined
continue,
not by the warmth of a
unfolding
nearby
in ways
sun,
we can't
but by
yet
the cold
imagine.
silence
The
of the
forces
void.
that created Quipu,
They drift
the
aimlessly,
cosmic web,
their atmospheres
and everything
and
we see in the
surfaces
night sky
continuously
are the same
bombarded by the
forces
elements
that will
of
carry us
space,
forward,
without the
even
shelter
long
of a
after the
gravitational
stars have
pull
gone
to
out.
guide them.
One
This
rogue
is the
planet in
universe we
particular,
inhabit,
known as
a universe full of mysteries,
CFB-DSIR
wonders, and
2149,
a universe that will
0403,
continue
is
to
located
evolve
roughly
and
100
expand,
light years
even
from Earth,
when we can
and
no
is
longer
unlike
witness
any other
it.
planet we have observed.
And perhaps,
it is a
in the
free-floating
quiet
planet,
final moments
meaning
of
it
the
does not
cosmos,
orbit any
the
star,
knowledge that
and
we have
instead
shared
roams
this
the
journey,
universe on its
even
own,
for just a
with a
fleeting
temperature
moment,
of around
will be the
400
most
degrees
meaningful
Celsius,
thing of all.
752
the
degrees
next time
Fahrenheit,
you look up at the stars,
CFB-DSIR,
remember, you are not just a speck in the vastness of space.
0403
You
is
are a part of
incredibly
it,
hot,
made of
and
the
yet
very
it is
same
cut off
atoms
from the
that once
energy
formed
and
the
warmth
stars
of any
that now
nearby
form the
star.
galaxies.
Its
and will
isolation
continue
is
to form the
profound,
new worlds
a
that
cold,
will come long
desolate
after we're
world
gone.
wandering through space.
Thank you for
alone.
joining me on this
The
incredible
implications
journey.
of such
Keep
rogue
looking up
planets are
and never
vast.
stop asking questions.
Not only
about
do
the
they challenge
universe we
our
call
understanding
home,
of planetary
you are
formation,
part of something
but they also
far
raise
greater than you
questions
can
about the
imagine.
true